Can you hear me, please?
Yes, sir, we can hear you now.
Okay. So first of all, I would like to thank all the conference committee members for having me on this International Conference on Computing and Innovation, ICCI 25. And the title of my talk is about computational intelligence in healthcare, navigating hope and hype, particularly in Pakistan. About me, there is just a bit correction that I'm working as an associate professor at the Department of Computer Science, Beijing University of Technology, China. I'm among the top 2% scientists as per the Stanford University list. I'm the senior member of IEEE and also the fellow member of Pakistan Academy of Sciences. I'm also the recipient of the Young Scholar Forum Award from the Marconi Society, along with Outstanding Graduate Award from the Ministry of Education, China. Beyond this, I'm also listed as the 100 top scientists in AI as per the AD Scientific 2025. Here is my brief research profile with respect to Google Scholar. So in today's talk, I'm discussing about the healthcare challenges and how we can mitigate all those challenges along with the different policymakers. So starting with the healthcare crisis, as we can see that most of the Pakistani people are living in the remote areas, and that actually provides some unprecedented challenges to overcome those kind of the innovative solution with the help of AI and some other solution. So with the rapidly growing population and limited resources, the gap between healthcare needs and available services, there is need to continue the widen. So Pakistan healthcare reality, the stats indicates that in the city areas, the ratio with respect to the doctors is doctor to patient ratio is 1:1,000, and this ratio may be 1:3,000 to 4,000 in the rural areas. There are more than 40% people are living in the rural healthcare access, where 1.4 million projected workforce gap that may be envisioned up to the vision of Pakistan government 2030. The growing burden, particularly with respect to geographic disparities, most of the people are living in the remote areas of Punjab, Sindh, and KPK. So these rural population faces several healthcare challenges with limited travel distances and inadequate specialist availability that may create some barriers for timely medical intervention. Urban overloaded, although there is the ratio, the doctors are seeing, current stats indicate that the doctors are actually seeing the patient for 40 patients a day, but this may the figure increase in some other cities. So urban healthcare facilities struggle with overwhelming patient volumes, creating the long wait times, strained resources, and obviously compromised quality of care for millions seeking the treatment. So what is actually computational intelligence? Computational intelligence is something we can actually use some different machine learning, deep learning, NLP, and computer vision based algorithms that may assist the doctors in such a way that they can actually reduce the burden of the doctors and the healthcare professionals. They may even help to maintain the history of the patients. They may help to provide some telemedicine for the people who are living in the rural areas, so they don't need to cover a long distance to visit a doctor. They may simply talk the doctor with the help of any kind of the expert system or telemedicine system, where they can simply give their vitals or simple kind of the symptoms, and they may actually be seen in the kind of initial treatments. So what is the promise for the real application? With the help of computational intelligence, this might be already transforming the healthcare delivery in Pakistan and worldwide, with tangible benefits for the patients and providers alike. As we mentioned earlier, that uh, people who are sitting in the remote area of Sindh, he don't need to visit some mega cities like Karachi and Lahore. He or she can simply give the symptoms, and then these kind of the computational intelligence based AI system can give them the initial kind of the diagnosis with respect to any kind of the disease, and then they can suggest that whether they have to visit for a larger stages or the next stages of the diseases. AI powered diagnostic, there is the example of Xilexa, um, revolutionary medical imaging techniques like X-rays, CT scan, MRIs. So this the Alexa actually provides some leverages for the advanced computer vision algorithms to provide fast, accurate medical imaging diagnostic, assisting caregivers in making critical decision. So in a simple way, this is something like in Pakistan, still one part of the medical imaging has been advanced a lot. If we talk about the X-rays or CT scan, still if you just visit in your surrounding, you can see that many doctors, they have to just simply put those kind of the X-rays in the front of light, and then they diagnose it manually whether a person having any kind of the knee injury or something like that. Even ultrasonic images has been advanced a lot, but still what the doctor have been doing, they just put the light on it and then they manually interpret the pattern behind that, and then they suggest that whether there are some kind of abnormalities or not. So if we talk about one aspect of the infrastructure that has been improved a lot, but another aspect that AI-based algorithms are not being properly equipped, or we are not actually been using, or we are lacking some kind, if they are exist, but the accuracy is not strong enough. So we have to look for those kind of the algorithm where we simply input any kind of the X-ray image, and then we can simply we can have the solution for that, or we can simply diagnosis for those kind of the X-rays or other kind of the imaging modalities. Telemedicine transformation, this might give some remote consultation. The people who are living in the remote areas, everyone nowadays have the access of the smartphone and even the internet facilities, so they don't have to visit physically for the doctors. Rather, they can help through with the help of the telemedicine. They can simply provide some symptoms, and they've been suggested with any kind of the solutions. Digital health records, with the help of telemedicine, you can simply keep track of all those patient histories. Patient histories are maintained rather than simply seeing a doctor for the first time. If the history has been maintained, and we see that history is one of the key concern in the medical domain. Also, AI assisted triage may provide some prioritized patient. If the patient has been in the serious conditions, they may been like uh, given the higher priority to check that and to provide some solution behind that. This might reduce the wait time for the patients. Predictive analytics, personalized medicine. This may come with the different steps, starting with the data collection, and obviously a lot of hospitals in Pakistan, they are actually been providing the data, but the data is not in proper order. Firstly, we have to maintain the data so that we can easily keep track the history, and we can easily keep track the diagnostic process. Based on the data collection, what we can do that we can perform any kind of the AI analysis, like we can do machine learning, deep learning, to identify the hidden patterns and predict the disease risk. Personalized treatment, we can give the personalized treatment that might be tailored as per the intervention based on the individual patient profiles. This might improve the outcome with respect to 20 to 30% better health result through this precision medicine with the help of AI-based solutions. The impact by the number, as I mentioned earlier, the personalized medicine can improve the healthcare outcomes from 20 to 30%. AI market growth, as per this CAGR survey report, Pakistan AI market expansion projected by 2025 is 30%, and it might reach up to 50% by the vision of 2030. It might reduce the diagnostic time up to 50%. So maybe half of the burden on the doctor, as we mentioned earlier, the patient and the doctor ratio is 1 ratio 1000. It might be reduced up to 500, 1 ratio 500. This is again still a huge number as per the WHO stats. The ratio should be 1 ratio 14, but it's not been possible. Uh, Even some kind of the innovative solutions, the reality check, the challenges ahead, and despite the enormous potential implementing computational intelligence, Pakistan healthcare sector still faces the significant obstacle that might be addressed for successful adoption. Critical barriers to adopt, there is a talent shortage. Only 1000 to 1500 AI experts are currently in Pakistan. So obviously with the passage of time, AI been evolving in every aspect. With respect to particularly AI, there is a need to train the doctors, all those healthcare professionals who are being actually using the AI actually, or implying the AI. They need to train how to actually use those AI-based solutions. There is a regulatory gap, although on the global perspective, federal drug authorities, FDA is already doing a lot of regulation. Like there are three classes has been already introduced from class 1 to class 3. The class 3 is something where all those like recently pneumonia chest X-ray based devices has been launched. So this is falls under the class 3. So this, but in particular in Pakistan, there's the lack of comprehensive frameworks that might govern AI in healthcare, creating uncertainty around liabilities and the standards. Infrastructure limitation, as we mentioned, that imaging techniques has been advanced, but still there are a lot of infrastructure limitation. There is inadequate digital infrastructure, particularly in rural areas, that might hamper the deployment of AI-based power healthcare solution, as we need that AI-based solution needs a lot of resources. So obviously, it may produce some hampers or some challenges, particularly in the remote areas. Funding constraints, limited investment in the healthcare technology, although the world largest companies like Google and IBM, they are already doing some wonders in the healthcare perspective. But if we talk about the Pakistan, there are still a lot of challenges in terms of the funding, acquiring, and scaling for the successful pilots. So there is the trust gap, building confidence in AI. As per this Andre Pirod, confident AI is something that the essential skills for working with AI. So healthcare provider and patients alike express concerns about AI reliability, data privacy, and the potential loss of the human touch in medical care. So there is some skepticism about the AI diagnostic accuracy, although the results are still promising. We are getting the accuracy up to 80s and 90s. That may be considered as a good, but there might be some challenges as the data is not um, uh, data may prone to error, or data is not generalizable. There is also fear of about the job displacement. If we work on the AI could be there to replace the human, but actually AI is to assist the human, not to replace the human. There are some privacy challenges, obviously, with respect to data, but still the solution are there that worldwide HIPAA, this is basically a Patient Privacy Act, has been already launched by the federal government, Federal Drug Authority in United States. And obviously, there are some cultural resistance to technology-driven care. Maybe one thing that is best fit in the US, but that might not be best fit in Pakistan as per the cultural challenges. So looking for the charting the path forward, strategic inventions across education, infrastructure, regulation, and investment can unlock computational intelligence transformative potential in Pakistan healthcare sector. So obviously we need take all those policy makers in one umbrella, that everyone should be trained as per the AI based education. There should be need to bring all those infrastructure. There is a need to take on board for the regulatory bodies, and there is a need some kind of funding companies that may give some investment for all those healthcare startups. So in all these combination, we can be looking for some path forward. Strategic interventions, invest in AI education, expand the digital infrastructure, create the regulatory framework, and foster the public-private partnership. Maybe we should look for some tech companies or some academic institutions to accelerate the innovation and adaptation. Pakistan unique advantages. Pakistan is been actually been blessed with young and tech savvy population. Most of the Pakistan population, around 64% of Pakistan population, is under 13. With increasing digital literacy and enthusiasm for technology-driven solutions that may create a fertile ground for AI adaptation. There is a growing IT sector. Pakistan IT export exceeded 2.6 billion in 2023, maybe 3.5 billion in 2025. So with a thriving startup ecosystem that actually demonstrate a strong technical capabilities and entrepreneurial spirit, global diaspora network, million of Pakistani professionals are working in a leading tech companies worldwide that may offer the technological transformer investment opportunities and international collaboration potential. So these key constraints actually provide us the motivation that why actually we should look for some AI-based startups, and why there is the need that we actually should come with the solution of any kind of the problem with respect to the healthcare perspective by using or implying AI-based solutions. There are some success stories with respect to global inspiration. India's Sanjeevani, this actually telemedicine platform, this might serving the million of people in the rural areas, and they are there to actually gather the data. They provide some basic symptoms and diagnosis of the diseases. Similarly, Africa's mHealth Revolution has been already launched. This was actually mobile first healthcare platform that was launched by the South Africa government that provide vital services through basic phones and SMS technologies. China's AI hospitals are already there. We are witnessing all those China's AI hospitals that provide advanced AI integration in urban hospital, showing dramatic improvement in diagnostic accuracy and operational efficiency. And the picture here is being generated from AI, but this kind of the picture has been from the real aspect as well. That recently China has been doing some surgeries based on AI-based robotics. So where we actually stand that there is a hope that AI is there to help the human, they are there to improve the diagnostic performance, but there is still a lot of hype. Um, the hype is something that AI is something, if we been not equipped properly, AI is going to replace a human and something like that. But we should look for a balanced view. The realistic hope is that AI can significantly improve the diagnostic accuracy, expand access through telemedicine, optimize resource allocation, and personalized treatment plan based on the robust evidence. Uh, the hype, as I mentioned earlier, that AI is to replace the human, but we have to actually avoid the hype. AI wouldn't replace the doctor entirely, although they are going to help the human. They are help to or even assist the doctors. So there is the need to solve all healthcare challenges overnight, work without quality data and infrastructure, or eliminate the need for human judgment and empathy. These are kind of the hypes, but this doesn't reflect on the realities. The ethical imperative, patient privacy is a key concern. Uh, whenever we talk about the computational intelligence in healthcare, there is the need that we actually look for some global acts like HIPAA is there to actually protect the privacy of the patient. Uh, Based on that patient privacy protected data, we can use it for any kind of the research purpose or for any kind of some kind of the development purpose. um, we are looking for some algorithm bias. Maybe we have been looking for some generalized algorithm that might be best fit for all kind of the disease diagnostic rather than looking for a single part or single kind of the diseases. So this is again kind of the challenging thing, but because most of the algorithms are providing some bias, maybe one algorithm is based on some specific data, and we may not put simply for a generalized data. There is the need of accountability to define responsibility when AI system make error. So AI responsibility, this is a separate field, and definitely it is something, whatever been provided by the AI, it should be clearly depicted or reflected through the help of explainable AI, which particularly factors or feature been producing, or what kind of the percentage of those features in particularly decision making. And equity is about ensuring AI benefits that might reach the underserved populations. Call to action, who must act? Obviously, first thing is about the government bodies, policy frameworks, infrastructure investment, research fundings, or regulatory clarity to enable AI healthcare innovations. Academia, AI focused curriculum development. So we have the AI degrees like the bachelor's in AI and a master's of AI. There is need for the research partnership with some kind of all those the companies who are working in particularly AI in healthcare field, and there is the need of the talent pipeline creations to build the expertise. Healthcare provider, there is also the call to action for the healthcare providers for the early adaptation. They should look for some pilot program. There is the need of data sharing among all the hospitals and all those research institutions In Pakistan, there is a lot of challenges with respect to data sharing as well. So there is the need to actually give the policies with respect to data sharing and continuous learning to integrate AI into practice. If we talk about the tech sectors or AI-based companies, there is the need of healthcare-focused AI solutions that might look for some local partnership or even some global partnerships and affordable technology to serve Pakistan unique needs. Key takeaways for today's talk is about the computational intelligence offers transformative potentials for Pakistan healthcare system. It gives some significant challenges that there is a need to be addressed systematically, particularly the shortage of the talents. There is the need of AI-based training. Infrastructure gaps are there. The third key takeaway is about Pakistan possesses unique advantages for AI adaptation. Most of the Pakistani population are under the age of 30. Pakistani IT sector has been already evolving worldwide, and there is the global diaspora network position where Pakistani people are currently heading some renowned companies worldwide. So all those being grouping and the collaboration can help to start the initiatives in Pakistan. There is also need of success that require separating hope from hype. So there is a lot of hype has been there. We actually look for some realistic expectation. We don't just consider that AI is there to basically replace the doctors, or AI is there to solve any kind of the problem overnight. Everything takes time, and it might be under some stages. So road ahead from 2025 to 2030, some recent 2025 to 26, there is basically need to establish some regulatory frameworks that may launch AI education programs, pilot telemedicine in rural areas from 27 to 28. There is this need to scale some successful pilots projects that has been launched. There is the need to expand the infrastructure, build AI healthcare workforce. Currently, we have around 100 to 1500, 1000 to 1500 professionals, but we may look for more than 5000 professional, or even this number may be greater in the coming years. From 28 to 2030, there is a need of nationwide AI healthcare integration by addressing 1.4 million workforce gap that might exist right now, but 2030 this gap may be much be bigger than that. So we just need to achieve some measurable outcome improvements. Join the conversation, shaping the future of healthcare in Pakistan. The journey from hope to reality requires collective action, informed dialogue, and sustained commitment from all those stakeholders, government, academia, and all those companies. So let's separate fact from the fiction and chart course for the computational intelligence-driven healthcare innovation that serves all Pakistan. So that's all from my presentation. If you have any question, you may ask, please.
जी Dr. Azhar, thank you very much for your valuable input.
No, or even we can say that there's a no uniform policy with respect to regulatory body in Pakistan. If we have to launch any kind of the system, there is a need. There is actually a need of mechanism that what are actually being aspects that might be needed to launch any kind of the system. So with respect to regulatory bodies like Pakistan Drug Authority, I think with the name of TRAP, Drug Regulatory Authority in Pakistan. First thing is that we need to take board the government and the drug regulatory authority body on board, that they should actually be launch any kind of the mechanism. So one should be aware that rather than if we be deploying a system and if gets successful and government asks to there, because there might be need of the privacy concern, the data leakage and something like that. So everything should be took on board. Like federal drug authority in the US, they actually launch a class 3 level regulatory body, class 1 to class 3. And class 3 is something where the direct kind of the intervention of the human has been required. Like suppose we they actually recently launched pneumonia x-ray chest based device. Simply you can put on your chest and they can simply diagnose is the person has been any kind of the pneumonia in the chest or not. So might be there are challenges, but for now, as there are no regulatory bodies are there, but we can launch, we can start from basically. It's again again the thing is that who will actually monitor all those things or who will approve that. Unfortunately, in Pakistan, there is no kind of for me, as per my best understanding, no funding bodies are there or no approval bodies actually are there who can actually approve any kind of the device or any kind of these AI based startups. So there is again the hope we can simply put in that gap, and the gap is there, and we can simply deploy any kind of the device which may look for computational intelligence based disease diagnosis or computational based intelligence for the healthcare perspectives. I hope that's it's clear now.
Ji, Dr. Thank you very much for sparing your precious time and giving valuable insight in the domain of computational intelligence in healthcare, navigating hope and hype in Pakistan. Sir, thanks a lot. Thank you very much.
Thank you, Dr. Saab. Have a good day. Allah Hafiz.
Allah Hafiz.
जी अस्सलाम वालेकुम डॉक्टर आयशा. डॉक्टर आयशा, can you hear me? वालेकुम सलाम. Yes, I can hear you. मैम आप अपना प्लीज काइंडली ऑडियो टेस्टिंग कर लीजिए प्लीज. Can you hear my voice? Can you hear me? Zamina, can you hear me? Yes, absolutely. So आप अपनी slides भी please share कर लें. All right, I'm just going to share my screen. I'm going to mute. आपका थोड़ा सा introduction होगा, फिर then you can start off. All right, just give me a moment. Sure. Please take your time. Can you see my screen? Absolutely. That's good. Thank you. We will now move on to our next speaker. It is my pleasure to introduce Dr. Aisha Obaid, lecturer and industry coordinator for SAS Vivia at the University of Technology, Sydney, Australia. She holds a PhD in applied data science and teaches courses in machine learning, data analytics, and visualization, while conducting research in generative AI and intelligent real-time systems. Please join me in warmly welcoming Dr. Aisha Obaid. Dr. Aisha, please continue. Zamina, can you mute your, I guess, mic because we can hear the reflections? All right. Hello, everyone, and welcome to ICC 2025. It's a pleasure to be here to discuss a critical shift in how we approach industrial AI. The journey from a promising prototype developed in a lab to a reliable, scalable, and high-performing model running live on the factory floor or in a critical infrastructure is fraught with unique challenges, especially when dealing with the real-time data and production-grade reliability.
Today, we are going to dive deep into this transformation with our talk from prototype to production, mastering real-time AI deployment in industrial environments. We'll specifically examine this challenge through the lens of crucial public service, exploring a case study on industrial MLOps for water demand forecasting in Greater Sydney region, where the stakes are incredibly high and the need for accurate and timely prediction is paramount for our resource management and system resilience. So, as we all understand that translational research or applied ML is a bit different than what we study in the books. So the first step is to understand who is the business owner, what the business do, and what is their target and what they want to achieve. So first of all, I would like to provide you a brief introduction about Sydney Water, which actually provide and provide water to the Greater Sydney region. So let's have a brief look at what Sydney Water do.
When the audio is not.
Sorry? Sorry? So you couldn't hear the audio? Can you hear me?
Ma'am, we can't hear this audio on this what you're displaying.
Okay, just give me a moment. Oh, I so we'll replay this video. This video will provide you a brief understanding, just in under 1 minute, what Sydney Water is and what's the role of Sydney Water in Greater Sydney region. Let's have a look at it again. I'm sorry for this trouble.
G'day. Ever wondered how Sydney keeps the water flowing? Sydney Water ensures a sustainable water future for Greater Sydney. Droughts are a big challenge. The 2017 to 2020 drought was a game changer. Storage levels dropped by over 50% in just 2.5 years. The Greater Sydney Drought Response Plan has it covered. Sydney Water promotes water-efficient practices and recycling. Exploring purified recycled water could cover up to 25% of needs by 2056. Sydney Water ensures a sustainable water future for all of us. So, next time you turn on the tap, remember the hard work behind the scenes.
So this is a brief introduction of Sydney Water. As we get this idea from the video that Sydney Water is a utility company. It's the biggest utility water supply company in Sydney region. And I would say in the whole Australia. And they actually provide, water to the Greater Sydney region. Now, what happened in previous years, like a decade ago almost, there was a drought and there was a shortfall of water, and they couldn't supply the water to the Greater Sydney region, which was really a tough thing and really not acceptable by people here in Australia. So they were actually trying to mitigate such happenings in the upcoming future. So they actually started to think about what is the business problem. So this is the step one, where you pinpoint your clients' pain points and you target that and tell them that you can help them out in solving that. So once you identify your client, once you identify the pain points of those clients, it's important to understand how they operate, what is the business process, and how we can transform that business process without actually disturbing the legacy system. And of course, the human factor is the most important, and we make sure that we do not threaten the jobs of humans and we do not replace people with AI. And because of that, human will be able to provide us the whole information that we need to create these AI-based data-driven intelligence system that can help us in decision support. one thing is very important to understand, that we must use AI as a decision support tool rather than making it a whole autonomous system. Because personally, I believe that whatever the scenario is, whatever the advancements are, I think the best AI-based algorithm is a human brain. That's it. So let's understand what was the problem, and let's see what were the operational areas of Sydney Water. So here you can see that the area of operation for Sydney Water is across these different sites where you can see the color coding. And these are the plant locations from where Sydney Water mainly provide water to the whole Greater Sydney region. Now, of course, when you have couple of sites or more than that to provide a specific utility service, then there is a need to make sure that you don't spoil the whole system, and you need to select one specific site for the proof of concept, deployment and testing. So we selected the Liverpool site, one of the Sydney suburb, to run this project when we have reached the final deployment stage. Now, because we were at the beginning of this project and we are at the stage one of translational research, the challenge is that we need to understand what the problem is. And the heart of this research is very simple. And it's a very, important challenge. That is to map an AI-driven system onto a standard legacy system to manage a sustainable water supply without disturbing the existing process. This is really very important. And then again, you have to go for client interviews, and you have to talk about the KPI alignment, what they think would be a successful, I would say, system. And what our clients said, they said that our current energy storage solutions are never designed to meet the modern demands in mind. Now we are asking these systems to do more than ever what they were intended to do. So we must think how we can create a sustainable water supply from the ground up. Now the thinking has changed, the era has been shifted, but the legacy systems are old, and the infrastructure is so big that it can't be changed. So in the second step, when we are trying to model their problem, we have to understand their manual processes. So here is the process flow diagram that you can see on your screen. So what happens is every day, one of the plant operators comes, they look up their data set. That data set is composed of an Excel sheets, where at 7 a.m. they would have a look at what was the demand of the water in the previous day, how much water they have released to the reservoir in the past one day, based on every location. So we are talking about Liverpool in this scenario. And then they would use Sydney Water's proprietary formula to calculate that what would be the rough estimated water demand for that particular day. Now, in Sydney, there is a sudden shift in temperatures all the day. Morning, it will be chilling. In the afternoon, it might be 35. By the time it's evening, it might be again 18 degree. So what the operators do, they actually go for looking at the temperature. They go for the Bureau of Meteorology data and see what would be the temperature throughout the day. And then based on if it's hot or cold, they would basically add on some value to the forecasted value, and then they will release that water to the reservoirs of a particular suburb. Now, they do the same process at 12 p.m. and 5 p.m. to make sure that they are actually providing the right amount of water the specific suburb requires. So this is their, all manual paper-based system, and the plant operator is the main decision power who has no help other than just the experience to decide what could be the real demand that is needed. Now, so what was the solution? We provided them an AI injection pathway for a sustainable future, and we provided them with two different sort of machine learning models. One could do the forecasting task and one could do the weather-based prediction task. So you need to basically analyze what is the system and how you can fulfill the requirement of the system. And in step 2, then you have to design your framework that can actually map the actual legacy system so that you don't disturb the system, you don't disturb the processes, but at every point of that particular system, you are providing them data-driven support. So what happened is we started with the data sources identification. It is really crucial to understand what sort of data you have got, because our I would say I'm not talking about only in Pakistan, even in Western countries, most of the organizations are not AI ready. There are no sources of data which are there for AI to be trained on. So we rely on what is available at the ground zero, and then we start training our models. And with the time, we keep on monitoring how they are performing, and we update the models. So at this point, when this is a very old legacy system with no information, so we relied on shapefiles from Bureau of Meteorology. We relied on their temperature data, their precipitation and evaporation data, again from the Bureau of Meteorology. And Sydney Water had just only a daily water supply information with that. So we did some high-level pre-processing. We converted those shape files, which were in polygons, into some lat-long values, and then we extracted the plant location-based weather data, and we combined them with the demand data on the previous basis and performed some feature engineering to find out what would be the most suitable features for our models. Now, this is really very important to understand that pre-processing in the industrial systems is not as similar as we study in the papers. Usually we talk about having outliers being removed, but in this scenario we did not remove the outliers because we wanted to make sure that what are the extreme demand cases, we model them in our prediction algorithms. Alongside with that, feature engineering is generally left for data scientist or the researcher. But in your real life project, please make sure that you consult the clients. Client engagement is really an important factor, and they would like their participation, and they do tell us what is available in the production, because sometimes you have got the training data, but the same data points are not available in the production environment. So we need to make sure that whatever we are training on our model are available in the production environment. So for that purpose, we need to engage our clients and provide them feedback. In real-time projects, it is really important to be very transparent with what we are doing, what we plan to do, and what would be the final output with our industrial clients. Now, when we have got our models ready, then we need to make sure how we are mapping it. So as we discussed that we have to go for multiple machine learning models to combine in a single framework to make sure that we are covering the whole points and whole decision points of the legacy system. So this is the same process flow diagram which we discussed earlier in this presentation. So this part of our process flow was covered by forecasting seasonal models, where we would have a 10-day plus forecast based on any special event. By special event, we mean that there might be some supporting event in a particular suburb, so we might need more water. There might be some special events, holidays, or things like that, or some specific leakage points that can actually result in an increased demand. So those are all covered in the seasonal forecast. So we every day, whenever one of the plant operators would open up the dashboard, they would be able to see the 10 days forecast. And those operators don't need to have much experience to forecast what they want to have in the next couple of days. Now, because we want to incorporate this part of our process flow model as well. So we have used deep learning models to provide weather-based prediction. And in the end, we are assembling these results to make sure that we have all that information which we have gathered through this framework available for the decision support. So this is the dashboard that we have designed. And you can see that it is providing all the information that we have. So in the first place, we have to select for the plant location. In this example, we have got Liverpool selected because that's the proof of concept site. And then we have got some information about minimum and maximum expected value of demand. So we provide them what could be the, buffer value they can think of. Then we have got the seasonal and weather-based forecast. And within the same dashboard, of course, you can see that every detail which is available is there. Actual versus predicted demand, whatever the plant, whatever the average demand is for the last 3 days, how things are going, everything is available for the decision support system. And we have also displayed the cumulative usage of demand from all the Sydney Water sites. It is really very important to have that cumulative forecast as well, because Sydney Water actually gets data water from Water New South Wales. So it's important for everyday use that the operators can request this much megaliters of water for the Sydney region. So this is how we actually go for developing our machine learning model based on the legacy system, and we can map it and make reliable, scalable systems. Now, when we are talking about the accuracy, of course, we look at maximum accuracy that we usually calculate using matrices that we have got for regression, classification, or different sort of problems. But you have to run your real-time prototypes for a good 6 to 7 months and look at the accuracies of how they are performing. And that would define how well you have designed your forecasts. What is the real demand and what your models were forecasting, that would decide if you have designed that algorithm in such a way that it is reliable, it is real time, and it is accurate. So these are the results from different sites, namely Liverpool, MacArthur, Mopsey, Pymble, Hermitage, and Cascade Orchard Hills. We have run this framework for a good 6 to 8 months, and we have calculated these matrices. Now, it is really important to understand about the project risk in such projects. For example, client engagement is one. You need to keep clients engaged. You need to have understanding of data sets, and data set could be really volatile. In many cases, for example, in this project, because this was really a complex client-based project, Sydney Water has got their own internal clients. So we got for, almost, I would say, we took 1.5 years to get the final data set. So data sets could be quite volatile because somebody would say ABC is the required data. However, the other client would come and say, no, it's the XYZ. Then you have to think about the modeling, how you model, because of course there are a lot of models, but you need to sometimes go for simpler models for the deployment, because they are actually sometimes working as good as complex models, and they are deployment is quite cheaper. So you need to think about that as well. And finally, the production. Now, with the software industry and AI being so much closely integrating these days, you need to know whether you are going to containerize your work, or you are going to use any sort of service provider. For example, in this project, we had our own private secure cloud, Vault Cloud, where we deployed this dashboard, and it has a very secure connection with Sydney Water. So all the data is there within Australia, and we are not using any public clouds like AWS. So again, based on the criticality of your project, you have to look around the production as well. So but of course, these are standard processes, and now we have Chris DM with us, which actually guides us to how we can go for implementation of data science project across different industries. So The first step, as we have explained, is the understanding of business. Then you have to go for data understanding. You have to go for data preparation, analysis, and then you have to go for presentation, visualization, which is very important, and evaluation. So these are basically 6 steps which we have to look at. And again, we have to see based on every use case, things are different, and we can always, uh, ask our clients what they want, because eventually they are the users and we need to satisfy their requirements as well. So, in this short discussion, we have navigated the complexities of deploying real time AI, moving our focus from the initial data science experiments to the rigorous demands of production ready systems. The journey actually is illustrated by our greatest Sydney demand forecasting case study, which underscores that success isn't just about building an accurate model, it's about establishing a robust industrial MLOps framework. Now, I'm happy to take any questions if there are any.
And Dr. Aisha, thank you very much for your valuable and comprehensive talk on Sydney water supply prediction system. Uh, I just want to ask that how can AI support Sydney water long-term sustainability goals such as reducing water loss, improving quality monitoring, or optimization of the treatment process?
When, for example, we have our 10-day forecast and we see that there is a sudden rise in the demand, it clearly shows that there is, it happens here very regularly, that the pipes are broken, something has gone wrong, and there's a water leakage, which actually hinders the sustainability goals achievement, right? So when you see a sudden rise in the demand from the previous days, then operators can clearly identify that within this region there are some water leaks, and they're quite quick in locating that, and then they fix that issue. So this framework actually provides us, the average usage within particular season with upcoming events. For example, if we are assuming that there is a sporting event, specifically, let's talk about Liverpool only. So what happened is, that why the demand is going high, because we have the days where the sporting event is coming up. So using these forecasting and these mean averages that I have shown you in the dashboard, you can see that we have a good view of what is the normal requirement of the water and what is current requirement, so we can clearly identify if there is some leakages or not.
Thank you. One more question I would like to ask that how we can utilize AI in real time to assist with the proactive leakage detection and pipeline condition monitoring that may also help to preserve the water and to fulfill the demand of Sydney, as water is a very critical area where all the nations are working, and how effectively we can utilize water and save the water for our life.
Now, within the Sydney Water, we have a very comprehensive control systems, and we have all the controls within the control room that can actually identify if there are leakages. So we have another project where we have actually UTS has worked with Sydney Water to find the parameters that actually indicates if there is a potential water leakage or not. So using those indicators, we have been able to predict them. This is not the same project. This is another project that we have worked on. So in that project, of course, with that particular data set that they had, providing the all the parameters that could that were off, or I would say were what we can say, that were not normal before any leakages. We call it anomaly detection methods as well. So we are able to identify the upcoming anomalies as well. Am I able to?
Thank you very much,
Any other questions? I wish we can have the similar system in Pakistan, but we don't have.
No further questions. Thank you very much, Dr. Aisha, for your time.
My pleasure. Thank you. Have a good day. Bye.
Thank you, Dr. Aisha. I'm Sadia Aziz, and now it's my pleasure to introduce Dr. Ghulam Mushtaba, tenure track assistant professor at Regis University, Denver, Colorado, USA. His research focuses on privacy preserving edge AI, human centered artificial intelligence, and next generation intelligent system. Dr. Mushtaba brings a strong academic and industry research portfolio, including a granted US patent. Please join me in warmly welcoming Dr. Ghulam Mushtaba.
Hi. By the way, can you see my screen?
Yes, sir, we can.
Yes.
Thank you. Sir, please proceed.
Okay. Thank you, everyone, especially Dr. Adnan, for giving me this opportunity to share my research. First, I will introduce myself. My name is Ghulam Mustafa. I'm currently assistant professor at Regis University, Denver, Colorado. So for today's talk, I will present the research delivering personalized content on Edge AI. So the core question, central question arises like how we can create efficient, personalized multimedia experience on resource-constrained devices like smartphones and set-top box within next generation streaming platforms. So the objective of the research is that we want to generate or deliver the content which should match for the individual preferences, as every user have a different preferences. Meanwhile, we want to develop a lightweight framework that can use for generating the personalized multimedia content. Meanwhile, we need to design a kind of solution which is optimized for the client-side implementations. So we will discuss all those in the next coming slides, what is mean by the client-side implementation and the personalized multimedia generation as well. Meanwhile, additionally, we want to discuss like create a solution that can understand both user preferences and device constraint. Device constraint can be the power consumption as well, along with the other parameters in smartphone devices or other devices. Additionally, we want to establish a new approaches for the next generation streaming platforms for that prioritize the personalization and the user privacy. Uh, do you have any question? Okay. Okay. So as Michael Kapoor said, that getting information nowadays from the internet is almost similar like drinking from the hydronet. So the recent statistics in sir, I can hear you. आप जो भी उर्दू में बात कर रहे हैं, if possible, kindly mute it. जी. In 2025, there are around 85% global traffic or the video streaming videos, different videos. Right now, as we are, I'm giving talk on using some platform. Most probably, you are watching maybe my face. I'm not sure because I have opened the camera. Meanwhile, you are also seeing the content like these slides on the streaming as a part of the streaming content. So there are over 500 of videos are being uploaded every minute in 2025. So 500 of hours of videos. Meanwhile, average adult in USA is watching around 7 hours of video content daily. So, and the typical streaming platform generate around more than 100 billion in annual revenue. And typical streaming subscribers now spend around like a 45 minutes just browsing the content before selecting and curating, which is a kind of significant decision fatigue. So it requires like almost 45 minutes if you are want to watch certain content on YouTube or maybe Netflix or other social media or other streaming platforms. Most probably you are spending 45 minutes just browsing, like checking, jumping on some specific content, maybe checking the specific needs like their thumbnails, animated GIFs, and so on and so forth, before actually trying to see the specific content. So there are different kind of choices we have. For example, if you want to read a news article, there are plenty of news, for example, based on our location, based on our language, based on other interest, like some people may like sports, some may like politics, some may like the other forms. So based on the choices, we need to figure out which news we need to watch. Similarly, if we want to watch a video on streaming platforms, there are many videos are there. Sir, can you kindly mute it, please? I can hear you actually. Thank you. So if we want to watch a video, like there are several videos, so we are not sure which video we need to watch. So if we want to play games, there are plenty of choices and games available. It's more kind of a decision again fatigue in order to select and play that certain game. And if we want to listen certain music, there are several songs or audios on there on different platforms. So it's really hard to make a choice. So there are so many options now out there in a different platforms. So it's really difficult to make a certain decision on a short period of time. So in the traditional approaches, the most of them are the server driven approaches or server side approaches. For example, there is a new broadcast video on the let's say Amazon Prime or other Netflix, other platforms. So based on the content, since server driven have already the video content and they collect the user data. So what they did, they generate the personalized content on the server driven solutions. Like they can generate the video summary, they can generate the thumbnail gif, and they can generate the other personalized multimedia content. But there are certain limitations, for example, user privacy. Since they are collecting user data and we are not sure how much their data is collecting, so it's very challenging to identify the data they needed for the certain operations. So there comes at the user privacy. Just for information, anything you are chatting with a chat GTP or other LLM based techniques, it can be used against you. So as in by law. So these all those server driven approaches, they are using they are using they are collecting the user's data. Meanwhile, the optimal video length, for example, one user may like a 5-minute summary, other user may like a 10-minute summary. So based on the user's preferences, server driven solution, they have to generate the content accordingly. And if there are overwhelming users, if we saw in during COVID time, even Netflix has to reduce the resolution for the certain region because there were so many users during the COVID era. Other thing is it's really hard to collect the real-time user interaction. Right now, for example, I'm giving lecture, and some people may are like reacting like they are laughing, maybe they are surprised, maybe giving some expression. So in order to collect those data in the real time is more challenging, and it comes with the again user privacy. So like the client device has to collect the data, and meanwhile the data will be transmitted to the servers site, and then it will be further processed, and then it requires extensive computational resources because video feature length videos or long form videos, videos which are more than 10 minutes, we call them long form videos, required computational extensive computational resources along with the storage and the bandwidth in order to process those videos, and challenging to handling the company devices. For example, if you are watching the content on the smartphone and if you switch to the laptop or other larger screen, how you're going to process those content. So right now the streaming platforms, what they are doing, they are generating the content. One size fits for all content. Like for example, if they are generating video thumbnails and animated, if you have observed on the YouTube, they are almost same. If let's say Muhammad is almost, if he's using YouTube on Pakistan, and I'm also using from USA YouTube, the same, I'm most probably seeing the same content, like on the recommendations. But meanwhile, every user have a different interest. For example, one user may like Mujtaba like the horse riding scene, and the Kim like the action scene. So based on the user interest from the same content, we have to generate we have to pay attention, because these content is very useful for the CTR. CTR is the click-through rates. So that click, the personalized content can like increase the CTR by 20 to 30%. So which can be really economically important for the different streaming platforms or different content provider, because they want more kind of engagement. So their user expectation for personalizing growing across all the platforms. There are industry shortcomings, like current solutions are primarily based on the server-driven solution. For example, Netflix and the YouTube, Amazon Prime, and Hulu, so on and so forth. And there are very limited personalization occur at the content selection. Like content selection is kind of recommendations. Recommendation and content generation are two different things, not the content personalization. So there are like a privacy concerns with the centralized users behavior tracking. So there the personalization have a three different dimensional challenge. One of them technical, like it required a processing real-time processing requirements. It has a bandwidth limitations. Meanwhile, they are existing with the we need to integrate with the existing platforms with a 1/10 of the server computation on the end user devices. Meanwhile, in their second challenge is the user oriented, like there are context and subject dependency. There are different contexts in the video. In videos, we need to process and understand, and there are varying personal preferences. As we discussed earlier, one user may like the action scene, other user may like the horse riding scene or romantic scenes. So, and their users' interests are keep changing with respect to time. It's really difficult to process those ones. And third challenge is the data. Like there are diverse inputs of farmers in the videos or in the general content. And there, as we discussed earlier, there are 500 or minute of videos upload rate. And it's extremely challenging to like generate the personalized content from those long feature length videos, because the scale of the data is so massive, so big. So in the proposed approach, like we did use the thumbnail container on the streaming platforms, on like let's say on YouTube. Most probably you are hovering the mouse on the video bar. So these I'm calling them thumbnail, and the 5x5 grid I'm calling them thumbnail container. So I'm the kind of first researcher who used those thumbnail in order to analyze the feature length videos. So the key advantage was that instead of processing the entire full-time video, which is 2 GB, what we did, we used the thumbnail containers, which are almost 5 MB. And then we were able to process them on the user devices. For example, in most of my papers, I have used the Jetson devices, Jetson Nano and Jetson TX2 as well. So we can, by doing so, we were able to generate the different multimedia content. Like we were able to generate the movie trailers, we were able to generate the obtain the animated GIF, and along with the video summaries. And then based on the user's interest, for example, one user may like the romantic scenes, other may like the action scenes. Based on the user's preferences, we were able to generate from the same video content. So there were some, this is the like proposed system architecture. There were some client-side components. The orange boxes that you are seeing, like event detection module and personalized detection modules, it can be developed or enhanced based on the user's preferences or based on the system's architecture or system need. Meanwhile, in the server-driven approach, there are two streaming platforms they are generally being used. One of them is the HLS, HTTP live streaming. Meanwhile, there is a dash, dynamic adaptive streaming over HTTP. So if you are using Apple product, most probably you are using HLS. HLS have a .ts extension in simply. And meanwhile, in Dash, if you are using YouTube or Google product, most probably you are using Dash, and they generally have a .mp4 extensions. So these are in the server-driven component side component. We have a HLS video server, thumbnail content generation, the playlist, and the segment processing. Because in the video domain, videos are being stored as the segments, like 10 seconds of segments in the server side. So there are four frameworks I have proposed based on in our discussion using the thumbnails. There are more than that, but like in this presentation, in this keynote, I have discussed the four one. One of them is a CL GIF, which is we can generate the GIF generation. Second one is the for the video summarization. Third one is the artistic media generation, like a thumbnail and the animated GIF. And meanwhile, recently there was another demo was I presented for the fast forward video summarization, which I will briefly explain over here. So in the CLA GIF, like in the mostly stories, there are like four uh, stages. One of them, the most important stage in the videos, are the climax. So what we did, we tried to use that climax part in order to generate the animated GIF, which is more kind of exciting. So the traditional GIFs are generic or one size fits for all, as we discussed, and they don't capture most exciting that matters for the individual preferences. For example, in the sports video, the crowd roll or goal movements, we can identify using the highest pitch. In movies, we can do this by the dramatic sounds, like again analyzing the different pitches, and we can generate the animated GIF based on the those pitches. And specifically from the climax part. So we use the audio analysis to identify the significant movements. So this is the algorithm for the proposed approach. There was a CNN architecture in order to identify, instead of processing all the videos, we just selected those videos which are users' interest, and then based on that, we were generated the animated GIF. So these are the proposed approach and the baseline approach, which was from the YouTube as well. And first one is the, I think, from YouTube. Second is baseline, and third one is the proposed one. And the second approach is the LTC sum. In the proposed approach, what we did, we like based on the user preferences. One user may like the, again, a horse riding scene, other user may like the shooting scene. So based on the user's interest, we were able to generate the video summarizations. So user need a quick video summarization, but as you might know, like 3D CNN require more computational extensive. They require more computational resources. Meanwhile, we use the 2D CNN instead of 3D CNN to reduce the computational while maintaining the quality of the summarization. But there are multiple use cases. For example, long lectures, we can shorten them, make the 10-minute summaries. We can analyze the feature films. We analyze the sports games, and along with the TV series, they can be further summarize. This is the 2D architecture. Meanwhile, we compare our results with the different approaches. Hector is one of the well known in the industry, which was developed by the Yahoo team. We proposed them based on our analysis. It required like 85 minutes to process the video. Meanwhile, our proposed approach only required around 2 minutes. So this is the generated video from the proposed approach. But the first one is the baseline approach, and the other second one is the proposed approach based on our thumbnail based technique. Third one is the FRC GIF. Like mobile devices have a low lack of computational power for complex video processing. So based on the user's preferences, we were able to generate the using the low lightweight frame ranking algorithm that works for the smartphone devices and the other resource constrained devices. So we develop another CNN architecture, which should be the lightweight enough to generate the different multimedia content. And this is the we analyze with a different approach. One is the host ATS along with the Hector. You can see that the difference between the proposed approach, which is analyzing more prominent or exciting scenes compared to the other approaches. So meanwhile, this is the animated GIF. In FRC, we analyze or generated two different contents, thumbnails along with the animated GIF using the FRC frame ranking algorithm. In the edge with some, we propose the new different approach. For example, in the video content have a vast OTT libraries, but it's really hard to navigate which content we need to watch. They are flow frame by frame traditional methods, which is again high computational resources are required, and there are privacy risk if we are focusing on the cloud-based solutions. So what we did, that this is the content, this paper is based on the patent which is already approved in the in USA and world as well. So this is the I have developed the technique based on the patent. So the patent was not a theoretical, but a more kind of practical one. So in the key problems, what we did in the proposed traditional processing, which can generate the like personalized summarization, fast forward semantic based on the user preferences, and by focusing those ones. So again, I use the thumbnail based techniques in order to use the generate the fast forward video summarization. So this is the demonstration which I have used in the CVPR. So what I did, I have developed the CNN architecture. You can like most of the details are available on my page, which is in the QR code in the last slide. I will show you in the first slide as well. So I developed my Chrome plugin along with the CNN architecture. CNN architecture was able to analyze which frame is important. Meanwhile, the Chrome plugin was able to fast forward those parts which are irrelevant to users' interest. Meanwhile, in slow speed or normal speed for those parts which is interesting for them. So these are the performance results impact, like based on the case study on the sports video analysis. Like if their video length is 1 hour 52 minutes, the processing time for the other approach is quite high compared to our proposed approach. Like for example, Hector, which was developed by Yahoo team, it required 85 minutes. Our approach analyzed in around 2 minutes. Meanwhile, the other performance metrics, like there was 70% reduction rate, because we were not analyzing the entire video. We are just using the thumbnail containers along with the specific segments. We were not requesting all the segments. Meanwhile, we have analyzed there are around 65% improvements in user satisfaction scores by doing the subjective analysis, and there are around 42% increase in the content engagement metrics based on our subjective analysis. So in the real world application and market impact, like we can use in the to different platforms. For example, we can use for the streaming platforms to personalize the preview and the trailers, user specific highlight reels, along with the actor focused content. Like as I mentioned earlier, we can generate the videos. Meanwhile, we can also do that for the social media, like generate the custom GIF based on the user's interest. By the way, this male and female is also generated by my proposed approach, which I present in one conference in IEEE conference. We can generate the content sharing optimization engagement based on the focus. Along with in the education sector, we can generate the personalized lecture summaries. Along with the student specific educational content, we can also do that. Along with the adaptive learning materials. So based on the user's need, we can modify the content, like but maybe summarize them, maybe fast forward or semantic analysis. So why this matters in 2025? Like privacy is the one of the main concerned in several countries, like that there are different privacy regulations. So our data never, in a proposed approach, data never leave to the devices. Meanwhile, there are rising costs, like a cloud and the cloud or server driven approaches require a lot of require computing and energy cost globally. So in our proposed approach, we require minimal server resources because we are processing on the end user devices. Meanwhile, we are meeting with the users' expectations as well, like by generating the content based on their need, along with securing their privacies. And in the market trends, their EdgeAI marketing keep growing, accelerating, and their personalization demand is also increasing with the privacy need as well. So the proposed approach is address all those trends simultaneously. So in the key takeaways, like a personalized media is essential for the next generation streaming platforms, and the client-driven approaches offer substantial benefits for privacy and efficiencies. The proposed approach demonstrates all those significant performance improvements in different areas. So remember, like in the cloud, your data is someone else's computer. Meanwhile, in AGI, your data is your problem. So at least it's our problem. So we need to focus it. So thank you. Yeah, I have concluded my presentation. If you have any question, please ask. Collect your data when you interact with the certain systems. For example, if you are using YouTube, they collect your data, like you, if you like the cooking one or education one or maybe the driving one, they collect all those interaction and save in the server driven approach. Meanwhile, in the client driven approach, we don't do that. We collect and keep all the information on the client side instead of the in the server side, because all this information, all those interaction, we those don't need to be transmit on the server side. Is it, do you have any other further question on this one?
Okay, 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 okay. Okay, so I have just one more question.
Yeah, sure.
Your results showed that a 70% of reduction in bandwidth usage.
Mhm.
So can you explain how the architecture achieved this reduction while still generating personalized multimedia content?
So first thing we need to understand, like we don't need to process the entire video. Maybe like I'm assuming you are in a computer vision or deep learning area. So maybe you know that in a 1 second of video there are around 25 FPS. If there is 25 FPS means 25 frames per second. So there are 25 frames, and most of the frames there are not too much information we can collect. Maybe 3 or 4 frames are needed. There are several different approaches researchers have used, where they are, in order to reduce the computational complexity, they are using 2 frames or 3 frames per second. So what we did, we used the thumbnails, which is a 160 by 90 pixel of small images, which I have showed you in the one slide. So the advantage is that, for example, if there is HD video, what you have to do, you have to downsize or downsample that image as well. If it's a, let's say 1024 by 1024, then you have to downsample and then you have to analyze it. Meanwhile, our image is already small. So what we are doing, we are using 160 by 90, and we are using for entire videos the thumbnail containers. So those thumbnail content based on our analysis, if a video was 1 hour 250 minutes, it's a 600 MB or 2 GB video, we can do the thumbnail containers are around, maybe let's say 10, less than 10 MB. So we are, first is this part that we are not analyzing entire video. Secondly, other thing is that when we are collecting for the video summarization or to generate the animated GIF, we are not requesting entire video content. We are requesting a specific segment from the server driven from the server side. In the streaming platform or streaming domain, as I mentioned earlier, there are two streaming protocols. One is HLS. HLS means HTTP live streaming. As I mentioned in my earlier, that if you are using Apple, most probably you are using HLS, which have extension .ts. Meanwhile, if you are using YouTube, most probably you are using Dash. So what we are doing in our system, we are using HLS. In HLS, you can manipulate each segment independently. So in the streaming domain is more kind of complex, but like simply we are using HLS, so we can manipulate specific segments. We don't need to request entire video from the server side. So that's how we are reducing the entire bandwidth. compared to the other approaches and the proposed one.
Thank you, Dr. Mujtaba, for your valuable talk. I'm Sadia Aziz, and it is my pleasure to introduce Dr. Bilal Ahmed, serving as an assistant professor. Ahmed.
Hello and good morning to all of you. Thank you very much, Professor Mohammad Asif, for inviting me to this very nice conference. And thank you very much, Mr. Meena, for coordinating. Thank you so much. So, the topic which I'm going to present today is Beyond Terrestrial, Unveiling the Future Generation of Non-Terrestrial Networks. Hello and good morning to all of you. Thank you very much, Professor Mohammad Asif, for inviting me to this very nice conference. And thank you very much, Mr. Meena, for coordinating. Thank you so much. Hello and good morning to all of you. Thank you very much, Professor Mohammad Asif, for inviting me to this very nice conference. And thank you very much, Mr. Meena, for coordinating. Thank you so much. So, the topic which I am going to present today is Beyond Terrestrial, Unveiling the Future Generation of Non-Terrestrial Networks. My name is Dr. Bilal Ahmed. I am working as a faculty member in the Department of Electronics and Electrical Engineering at Middle East Technical University in Turkey. Before joining this university, I worked to a very famous and well-known research group in the domain of satellite communication from University of Bologna. So I worked there as a postdoc research fellow. Before that, I did my PhD again from University of Bologna in the domain of satellite communication systems, specifically in non-terrestrial network systems. I have been involved in several European Union funded projects. So most of the work which I'm going to present, I mean, not most, I mean almost all of the work which I'm going to present today is part of European Union projects. So I worked in a very close collaboration with University of Bologna. And a very thanks to my professor at University of Bologna, who is also my supervisor, Professor Alessandro. So in the beginning, I'll try to make some concepts very clear to you so that once we go deep into the presentation, you know these sort of concepts. So in wireless communication, we have two types of communication. One is terrestrial networks, for example, 4G, 4G LTE, 5G, 6G, and who knows what is going to be evolving in the next several years. So, I mean, you already know about these networks, you get high data rates, and I mean, these networks are amazing. But then there is another example of connectivity, and these type of networks are known as non-terrestrial network systems. So previously, I mean, satellite communication was very much known for its uh, broadcast television channels. So we usually took into account satellite communication as geo synchronous Earth orbit satellites. Then for the navigation, we used to work on medium Earth orbit satellites, and then we had LEO. But now, you may have gone through the literature, state of art, where you have unmanned vehicles, you have drones. So the classification is very simple. You look up to the sky, and if you are getting the connectivity from the sky, then you classify this as non-terrestrial network systems. So once you start comparing, okay, so terrestrial network systems and non-terrestrial networks, once you start comparing, both of them are very different to each other. How they are different? So terrestrial networks involve densification. So you know, okay, you need to have more equipment on ground, you have base stations. Once you go to satellite communication or non-terrestrial network systems, you need to be launching a satellite to the sky, and this is a very difficult process. Plus, you have something which you don't have command. So if you fly a rocket and the satellite is being launched, so then what is going to be happening? Okay, so this is something a one-point design. You design something, you float it, the satellite, and then that's it. But what is the importance of your non-terrestrial network system is that you know that you have 70% of water, and then okay, your ground and earth is not flat. So what you need to do is you need to be having two mobile towers, and they need to be line of sight. So if they are line of sight, then yes, you are going to have a communication. But you think about this aspect, this is a very challenging sort of thing. Okay, instead of this, if you are looking up to the sky, whether you are in the ocean, wherever you are, if you look up to the sky and you manage to get connectivity, the problem of connectivity is being solved. And then in terrestrial network systems, there can be several base stations after several kilometers. So I take you to a very nice calculation where you need to find, okay, how many base stations for terrestrial networks are required to cover an area of 2 into 10 raised to power 6 square kilometer, with the base station covering a radius of 1 kilometer. Okay, so if you do this calculation, what you see is that 6.30 million base stations are required, covering a radius of 1 kilometer. I mean, think about the whole universe. I mean, there are places where you are unable to mount the space station, and this is quite a very massive number. So, what are going to be an alternative? So, the alternative is, let's suppose, okay, so at a height of, let's say, above 36,000 kilometer, if you have a floating repeater, you can cover one third of the Earth. So this is something which refers to geosynchronous orbit. Now, satellites, what are they? Okay, so why there is need to have satellite communication or non-terrestrial network systems. So base stations are less than 100 meters. And if you want to cover more geographical coverage, we need to increase the height of the base station. And can you mount an antenna at a height of 36,000 kilometers? So this took us to Arthur C. Clarke. Okay, in 1945, he presented a seminal paper, and what he said that at a height of 36,000 kilometers, if you have three microwave repeaters in geosynchronous orbit, you can enable intercontinental communication. So simple, what you do is you with the help of a rocket, what you do is you take this floating repeater, and this satellite is nothing but a microwave floating repeater. So what are the advantages and disadvantages? Okay, so once you compare it with terrestrial networks, there are a lot of advantages. For sure, there are so many disadvantages. And what we see these disadvantages as an opportunity. So you can think about your carriers and requirement of high reliable design. You need to be having high reliability. So things like FPGA mounted on satellites, it is a very nice and new dimension which is, I mean, taking existing existence in so many European Union funded projects. One point failure. So, okay, so how you are going to fix that? Okay, so reconfigurability is something. It also requires heavier launching rockets. So people from electrical engineering, aerospace engineering, they are working on this sort of thing. Again, on-board power supply, electronics, electrical engineering to work on this. Tracking and monitoring of satellites, people from computer science, computer engineering, electronics, electrical engineering, all of them, they can work on these sort of domains as well. But advantages, it provides a reliable solution to the last mile problem. You don't have to dig the roads. So it is easy to set up once you compare it with terrestrial networks. For disaster, for defense, once you have nothing, you look up to the sky, you get the connectivity, and here is your solution to the problem. Fairness of services, so video on demand. Long life, okay. So could be 20 years, 25 years, depends on the manufacturing people. So as I explained before, Okay, so the satellite is nothing but a microwave repeater. So you transmit your signal to the satellite, then you need to have an amplifier, and it sends your signals back to the ground. The most important thing is, of course, the propagation medium. Okay, so the propagation medium in your non-terrestrial networks is different as compared to terrestrial networks. Why? Because things like rain, atmospheric losses, barometric pressure, oxygen, nitrogen, which does not make sense in your terrestrial networks, but they do make sense in your non-terrestrial network. So channel modeling is something which is again a nice domain to be working on it. Then the purpose of this slide is just to recap something. So ITU do the spectrum region-wise distribution, and what we are seeing is the bands from L to Ka. So the voice communication is being done at 2 to 4 gigahertz, and for broadband 26.5 to 40 gigahertz. So the European projects which I am going to introduce. For the voice communication, we did this sort of, we considered this sort of frequency, and then for the broadband, we consider this sort of frequency. And one thing, what we require is that we need to require it higher data rates. And for higher data rates, what you need to be doing is you are required to go to the higher frequency. So higher frequency means higher throughput. But okay, so if you are having higher frequency, what you are going to get is shorter distance communication, right? Because of shorter wavelengths. So how to improve the coverage? Then you get into the domain of multiple input and multiple output systems. So you go for either cell-free MIMO. This is something, I mean, this is a very interesting domain, and you see a lot of research going into multiple input and multiple output system. But of course, spectrum is a very sacred resource, and the topic which I am going to discuss is also interference management and mitigation techniques, which is to effectively utilize the radio spectrum. So now we have some understanding about terrestrial and non-terrestrial network systems. Now, what I want you to be referring is that you see, okay, from 2.4 kilobits per second to 1 to 10 gigabits per second. This is something the expectation we are having from 5G. And from 1G to 5G, generation of mobile technology attempted to meet the needs of end users and mobile operators. And the new development of data-centric automated processes may exceed the capabilities of 5G systems. And we are calling it as a new wireless generation. So 5G was evolved considering three use cases: ultra-reliable low-latency communication, enhanced mobile broadband, and massive machine-type communication. But in 2030, we are going to considering something which is rural connectivity, public safety, network resilience, network automation. What is going to be the role of public energy and environment, reducing carbon dioxide emissions? So this is a very nice paper, and I strongly encourage you to go there. This is from University of Bologna. We have people from Thales Space, and for sure, I mean, there are so many other people from well-known industries. So please go and read this sort of thing. But the crux is that, okay, the need of 6G or the enabling of 6G is due to the advancement of your artificial intelligence and machine. So now we know that how much internet is useful. Okay, so the purpose of this slide is, okay, even those countries who are progressive and they do have 5G, you see in 2019 there was a hurricane in United States of America, and what is the outage in terms of network connectivity? So people were there out of internet, even America. Okay, they have this problem of network congestion. Then if you consider a football stadium, so how you are going to fix this sort of thing, even if you are providing 5G connectivity or maybe in future 6G connectivity. So it is directly coupled to the geographical area. What you need to do is you need to be densifying the network. So is it a good and reasonable way to bring more equipment to the stadium? Okay. So in 2018, 55% of the global population lived in urban areas, and 67 had mobile subscription, but only 3.9 billion people were using the internet. So majority of the people remain unconnected with this 5G, 6G, though where these 5G and 6G networks are being deployed, people are getting very good data rates. But then the problem is, when there is a disaster or there is any problem, you have no access to now the importance of non-terrestrial network systems. So 3GPP started working on non-terrestrial networks in 2017, and this is the first release where non-terrestrial network use cases were considered. And they now everyone admire that satellites is a viable solution, and this is a solution which is not constrained by geographical environment, and we need to be providing connectivity because this is the fundamental right for everyone. So what you see is Geo, Meo, Leo, and you are coming down to 100 meters. So from 35,000 kilometers, you are coming down to 100 meters. Okay, so advantages and disadvantages. We keep this sort of things in a very simple fashion. So if you are there in Geo, you require
Assalamu
3
alaikum
satellites.
and
Okay,
good
that is something which we explained earlier. So you have less number of satellites means you are going to have less number of handoffs. But what is the problem? As I said to you before, the satellites are nothing but a microwave repeater. So you think about this distance of 35,000 kilometers, which is bringing a lot of latency, which means that the applications such as imaging for high resolution or the communication applications which require low latency are not going to be practical with these sort of orbital satellite. So for sure you need to be coming down, and LEO is something which is a huge attention. And then you see Starlink, okay, they work on VLEO. So what you need to do is to have a mega constellation, let's say, but what will happen is, yes, you are going to have large number of handoffs. The gateway cost is going to be very expensive, but the propagation loss is going to be least. And because of the least propagation loss as compared to your geo satellite, what you are going to be achieving is low latency communication. So now, okay, whether to go for terrestrial network standalone or to go for non-terrestrial networks standalone. Uh, then, okay, because we are academicians, so yes, what we realize is that we want to have research towards internet for everyone, and that is something which brings us to a collaboration, and this is something which is a very, very important research domain, and for the next 10 to 20 years, trust me, this is not going away. So what is this? This is the integration of your terrestrial networks with non-terrestrial networks. So you deploy your terrestrial network. In case of a failure or in case of any problem, what you do is you get backbone connectivity from non-terrestrial networks. And the key enabling technologies for the next generation of wireless communication, which is 6G, is antenna design advancement, spectrum management, channel model, which could be millimeter wave or terahertz communication. Okay. Again, I would strongly advise you to go and read this paper, which is from Professor Alessandro Guidotti. It's from University of Bologna, and he was also my co-supervisor. So this is a very, very nice white paper, which reflects to architecture, services, and technologies towards 6G NTN systems. Okay, so what are the challenges and opportunities? And this is something which is leading us to my contributions towards the European Union projects, which I mentioned before. So spectrum for satellite communication is limited, and you know that to make use of the spectrum effectively and efficiently, what we do is we use frequency reuse techniques. And to improve the transmission data rate, several spot beams are generated on ground. Now these days you find that aggressive frequency reuse are being deployed. But because of this, what you are going to get is co-channel interference. So if you want to improve the sum rate capacity of the system, what you need to be doing is you need to be mitigating CCI, which is the co-channel interference. So you may, try to think about interference mitigation by the illustration of this nice figure. So what you do is, let's say for simplicity, you have a standalone LEO satellite. at a height of, let's say, 600 kilometers. Then you have several spot beams for the coverage. Uh, and then what you are going to have is a large number of users. So what is this problem? This problem is that you have so many number of users uniformly distributed. I mean, in practical situations, these are not uniformly distributed, but because we have to consider, uh, we have to build the preliminary. So what we say, okay, these are uniformly distributed, but what you see is that the number of users are very, very high as compared to the resources of your satellite. And by resources of satellite means what? The antenna element. So even if you are mounting a uniform planar array of 32 cross 32, which gives you 1024 or 1024 antenna array elements, and then you are having 1000 users, so this equation does not satisfy. Okay, so this type of problem is known as NP-hard problem. So how to solve this problem? So what we suggested is that, okay, what you do is you have several time slots, and for every time slot what you need to be doing is you are going to be performing some clustering algorithms. What these clustering algorithms are going to be, for sure we know that these are going to be ending up with suboptimal solutions. Okay, and then what we also need to be considering that, okay, these are European Union projects and we need something very practical. So what we need to be doing is what? To have some practical solutions which do require low computational complexity. So the problem is simple: investigation of user scheduling algorithm. I mean, the problem is simple, but the solution is not simple. And what we really wanted to do is to maximize the sum rate capacity. So in the state of art,
We did a very,
for
very
sure you
massive
need to be reading
investigation
all
at
these papers,
University of
but I
Bologna.
will
We
try to give
investigated
you
each and every bit of user
equipped with
scheduling, and
several
now
concepts. So once you go
we
and
are
you try
at a
to read
stage
these
where
papers,
all the
you are
scheduling
familiar with
techniques
them.
which are being
Okay, so
adopted
there
in
are two
satellite
types of scheduling
communication
algorithms. Once we discussed
are most of what
non-terrestrial
we
network,
have presented
and
as
I
the
have
University of
explained to you
Bologna.
that
Okay, so why user scheduling is
channel
very
model for
important,
your
I
non-terrestrial
already
network is
explained to you.
different.
If
Why?
you go
Because
to the
you take
state of art,
account
you will find there are two
uh,
different types of
rain
scheduling techniques
attenuation,
which are being done in
water
satellite
vapors,
communication.
nitrogen, etc.
One is known as
So
user
there are two
selection,
types.
and
One is
another
user
one is
selection,
known
another
as
one is
user
user
grouping or
clustering.
clustering. So
So
user
user
selection scheme is
selection is
something, okay,
typically
what you do
performed
is
once you need to find
you
out
you
the
select
performance
the
rate. Okay, but the
best
problem is that
users
these are
having
not
the
going to be
best
served
channel
at
gains,
the
and you serve them.
number of users.
But then the
So
problem
the
is
channel
with the
conditions
channel.
change.
So if you are going to the
There are user
some
grouping and clustering. Before
violation
we
of
went
the
into
condition.
this
So
sort of
let's say, I mean,
topic,
those users are
investigating
going to
for
be
the
remain
European
over
Union
there if
projects,
you are
we
not having
investigated
any
the
links.
state
So
of art,
you
and
have to
a
wait
very
for
well
them. On to
and
user
what
grouping and
basically
clustering
happens
algorithms.
at
So
that you get
we
a
said,
very
okay, what we
suboptimal
do is
solution.
we are going to have different time slots. For each and every time slot, we will try to find the best users such that they they are totally orthogonal to each other. Why? Because we want different users to be there. If we want to have same set of users to a cluster, then what will happen? It will be a downgrade or degradation of the performance. And what is the performance? It is your spectral efficiency, bit per second per hertz, or your throughput, okay, bit per second, or your sum rate capacity. So, so what we did is we started our journey. We started uh, re-implementing some of the state of the art, and this MEDEC is a very novel algorithm. So we try to compare our proposed solutions with this sort of algorithm most of the time. This is something which refers you to the path loss. So you see, for terrestrial networks, the path loss is different, but you need to be adding these two losses once you go to non-terrestrial networks. So now coming to the system model, which we adopted in the European Union funded projects, was a multi-beam LEO satellite. Then we took account ITUR recommendation, and then what we also considered was 3GPP specification. So the entire summary is going to be what, that we wanted to get a channel matrix, and based on the channel matrix we wanted to consider a decision policy where we effectively use this sort of decision policy, and then we cluster the users such that to improve the maximum sum rate capacity of the system. Now this is a very practical channel modeling thing. Users immense utilities in every field. So what we said was, okay, we have number of users which are very large. So we said, okay, now we have number of users and we want to construct a graph, but how we are going to store this graph, because the computer does not know what a graph is. And once we have the graph, how we are going to decide, okay, which users need to be in cluster 1, 2, and how many total clusters are going to be there. So as I said to you, this is NP-hard problem and we are not getting a square matrix. So what we did was to first we consider the channel state information, and then we computed a coefficient of correlation matrix. Based on the coefficient of correlation matrix, what we did was we found the threshold of the graph. And once we found the threshold of the graph, what we found was a click. So a click is defined as the largest network within a graph. These user scheduling algorithms are presented in DynaSet, which is a European Union funded project, and it's been completed. My PhD was supported by this project. University of Bologna was the coordinator. University of Parma, Martel, Thales Space, Fair Spectrum, we all work together to come up solutions for dynamic spectrum sharing and bandwidth efficient techniques for high throughput MIMO satellite systems. So I would strongly advise you, suggest you to go and read the website of DynaSet. And what user scheduling algorithms I explained to you. This was presented in a very prestigious conference, ASMS, in 2022. So we took a channel matrix, we computed the coefficient of correlation matrix, we found the threshold, we optimized, we found the click, which is the maximum click, and then we created this joint set. Then we further investigated more algorithms, and then what we presented in EUCSC 6G Summit, again it was a part of DynaSet project. So we considered location-based clustering. So once you go to non-terrestrial networks, not necessarily you need to be computing the channel state information. So what you can do is maybe you consider what the location-based clustering. So this is something which we investigated and we compared with the position-based random scheduler, which used to find a constant number of users in every cluster. MEDEC is something which I explained to you. This is being presented by NTO's now. This is non-graph-based solution, and we compared this with CSI-based maximum click as well. So we did threshold optimization, we try to find mean cluster size. You see in the random scheduler, it is 91. But this is an important finding, comparing CSI with distance-based max click. So we were having an improvisation. Again, I would suggest you to please go and read this nice paper. Then this ended up our journey in DynaSet, and we went to another project, which is 6G NTN. And this is a very massive project. Maybe, I mean, by the end of next year, this project will be finished. It is on the last stages, and you see Orange, Thales Space, quite a lot of industries are there, and this is a very massive project. German Space Agency is also there. and University of Bologna uh, is the one who received this funding. So for this, we presented in ICAS to 2023 improved clustering. So what improved clustering was basically, I mean, we were trying to find the threshold optimization for the entire graph. Differently, what here we did was for every time slot, we tried to find the gradient to a very nice results. This paper also took account Ka band. Previously, the papers which I explained to you or the work which I explained to you, which are part of the projects, considered S band. So and then we also modified the MEDC algorithm, which is non-graph based. It was not our algorithm, but what we did was instead of finding the coefficient of correlation matrix, we migrated the design to a distance-based MEDC. So this paper was presented in a very prestigious conference for Ka broadband communication, and it was nominated for the best paper award. Now this paper is also invited for IJSCN, which is a very prestigious Wiley journal. You can go there and you will find it a very interesting paper. Then we also considered that okay, we need to be working on computational complexity. So as I explained to you, this is a very important subject. Why? Because in graph you have nodes and you have edges. So what we did was we solved this as a graph coloring problem such that to reduce the computational complexity. And this paper is presented as location-based user scaling through graph coloring, and we went from the traditional spot beams to self-read. The key contributions are Dynaset projects, 6G NTN, 5G Stardust, and Eager. What I really want is, apart from my contributions, what I really want you to be considering is to go on LinkedIn and go to these websites and see what these projects are doing. This also add up to my presentation for sure. I mean, it was just 20 to 25 minutes. I have no idea. Maybe I am a bit longer, maybe 30 minutes. At the end, what I will also like to mention is that here at Middle East Technical University, we are looking for collaborations as well as I have a project which is a funded project. So I'm looking for resources in terms of scholarships for master students, and the topic is going to be secure satellite communication systems. If you need any information, you want to apply, please feel free to communicate with me using my email. In case you don't have my email, please ask and request from your coordinators or maybe your conference organizers. I wish you a very good conference. Take care and enjoy the conference. Thank you so much.
Dr. Tahir, and today I'm going to talk.
Thank you, Dr. Saab. Next, we have Dr. Ataur Rahman with us. Dr. Ataur Rahman, Associate Professor at the College of Computer Science and Information Technology, Imam Abdul Rahman bin Faisal University in Dammam, Saudi Arabia. With more than 150 research publications and expertise spanning digital communication, DSP, AI, and applied soft computing, he is prominent contributor to research and education in advanced computing domains. Ladies and gentlemen, please welcome Dr. Ataur Rahman.
Talk about digital image watermarking in deep learning era. Dr. Tahir, and today I'm going to talk about digital image watermarking in deep learning era. We'll be talking about some challenges and opportunities. Before I start, I just would like to share with you that why I actually picked this topic among so many topics that we can have or I'm currently working with actually. There are certain areas that they're not new, but mostly they're influenced by the traditional approaches like statistical approaches, spatial domain approaches, frequency domain approaches. So I'm talking about, for example, 2 decades back when we were working on digital image watermarking. But now I will know that deep learning have revolutionized the entire paradigm. And the thing is that how can we come up with the new ideas and where potentially we can employ deep learning so that we can get more benefit out of it, and we can see that how digital image watermarking can be benefited from this technique actually. So this is the main purpose behind picking up this idea. So this is actually an older idea which was very much celebrated by using traditional techniques. But now, because we are now in the era of deep learning, machine learning, AI, and whatnot, so we want to see that what potentially areas in the paradigm of digital image watermarking, where we can utilize deep learning, and what potential benefits we can get out of it, what potential challenges could be there, and what are the potential opportunities. So in this regard, the agenda for today's talk will be that I will introduce the topic. I'll give some quick background about the digital image watermarking, particularly the requirements that are there for the digital image watermarking, what potentially we need over there. Then we'll move on to the challenges that are encountered, particularly in the traditional techniques. And then where it comes the presence of AI, machine learning, and deep learning. I'll actually love to go with an emphasis on medical image watermarking. Then we'll go for some opportunities for digital deep learning in digital image watermarking, and then I will summarize and conclude it. So first we start with the quick introduction to digital image watermarking. So basically, watermark is a secret message that is embedded into the cover message. So these messages could be of any type. For instance, they both can be voice, they both can be images, they both can be text. They can also be alternative. For example, we can embed voice into, for example, image. We can embed text into image, we can embed image into image. So these could be of any type. So secret message can be of any type of media, and cover media message can also be any type of media. So usually only the knowledge of secret key, formula, or mathematical function allows us to extract the watermark at the receiver side. So basically, before transmitting the media over some channel, the information that how to extract is usually available with the receiver in the form of some secret key, some formula, or some mathematical function. A quick difference between cryptography and watermarking, I would like to tell. In cryptography, we yani, cipher the image, or we cipher the data. It is purely imperceptible. But in terms of digital watermarking, the main image or the main message remain as it is. However, secretly we hide the watermark inside. So for a variety of purposes, for tamper detection, for copying detection, for different kind of attack detection, and so on and so forth. So this will come in the discussion. It has a mathematical property that allows us to argue that its presence is the result of some deliberate action, if there is any. As far as the effectiveness of watermark is concerned, it's actually a function of robustness, how much it can withstand some certain attacks, capacity, how much payload we can insert into the cover image. Imperceptibility is after inserting the watermark, the image or the media will remain imperceptible. It will remain unnoticeable, especially at least for the naked eyes. Why we need watermarking? There are a lot of reasons. There are a lot of areas, as you can see in this image, where the watermark can be applied, and it has been utilized for years actually. For example, ownership or copyright assertion, for sake of authentication, copy prevention and control, content protection, fingerprinting. In terms of imaging, for instance, when we talk about medical images or legal documents or legal images, so it's used for tamper detection or attack protection. These are few of many application areas that we need watermarking there. So protecting digital intellectual property is crucial to prevent infringement. Advances in digital generation, storage, and communication have led to new risks actually, because this is era of digital media production. On the daily basis, we have been producing a huge amount of data all across, and at the same time, we want that it should be protected. So what we want, what the risk potential we can have are unrestricted copying of the digital contents, easy forgery and unauthorized editing, attacks on sensitive data like electronic health record, in particular in the case of medical images. Lack of protection raises concern in critical sectors like healthcare, businesses, and defense. So watermark is a widely used technique to secure data against illegal interferences. So why we are talking about digital image watermarking in the deep learning era? Because digital evolution has increased the need for watermarking to protect multimedia from unauthorized changes. On the other hand, deep learning has become a key focus in watermarking research, offering new architecture and solutions. Deep learning-based watermarking methods have shown superior performance compared to traditional techniques in their earlier experiments. So this session reviews a recent development in both conventional and deep learning approaches to image watermarking in particular. And we also see the effectiveness of deep learning watermarking that depends upon the chosen network architecture, especially in terms of invisibility and robustness. So now we'll quickly go through some background, because for those listeners, especially who are new to this terminology or technique, so quickly we'll give them some background, then we'll move on to the main part of this talk. So when we talk about the watermarking system, there are three main components. Firstly, the generation function, which is used to generate the watermark signal itself. Secondly, the embedded function, the way the art of embedding that generated signal or the message inside the target message, the target media. And finally, extracting, reversing the watermark out of the watermarked media, especially the images. So if you look at these two pictures, so the left-hand side is showing the encoder diagram, while right-hand side is showing the decoder diagram. On the left-hand side, we can see the original media is coming. Firstly, we apply some kind of transformation. So now we are getting the transform media. And now we are having the information to embed. We generate the signature. And that signature is embedded into this transformed media. So this embedded, so this is embedding based upon some embedding algorithm. So the resultant image will be the watermark image. This is the image that will be transferred over the network. Upon receiving, that is passed to again the transformation to get again the effect of transformation back, and then we apply the detection algorithm, and then we will get the original media as well as the watermark. In certain cases, we will see that the watermark extraction, sometimes it's mandatory, sometimes it's not mandatory. So that's why it could be yes or no. So that is something that we'll talk about in the later slides. As far as the watermark classification is concerned, it has been used to a variety of media for a variety of purposes. For instance, when we talk about the classification, so sometimes in terms of perceptibility, sometimes watermark is visible. For example, when we are watching some news channel, so you can see the watermark, it's visible on the television. In terms of invisible, we can have robust, semi-fragile, and fragile. Robust means it will withstand any kind of attack. Semi-fragile, it will behave 50-50. And fragile, it will immediately speak about that whether some forgery have been held. In terms of host images, we can have audio, video, image, and text. These could all potentially be the host signals. The type of procedure that we apply, it could be non-blind, semi-blind, or blind. The way that we extract the media, the way that we extract the watermark at the receiver side. There are two domains where the watermark has been embedded. The spatial domain, it contains least significant bit method, spread spectrum method, correlation, and patchwork method. In transform domain, we have different kind of transform like Weber transform, cosine transform, singular variable decomposition, and so on. We can have private, public, perceptual, and bit stream based watermarking system. So this is the general paradigm, general classification of the watermark that we use. So we can classify them according to their types. So robust, they survive against any kind of manipulation against the image. Fragile will detect manipulation. It is usually used for the authentication purposes that we need to make sure that everything is fine with the host image. Semi-fragile will be having some robustness as well as some authentication. According to their method of insertion, we have additive method where the watermark is embedded into the host image by means of manipulation of the bits of the image. We can have quantize and replace. We sometimes replace the bits of the source of the target image by the watermark. In terms of domain of insertion, as we talked about earlier, so we have transform domain, usually frequency domain or wavelet domain. And we are also having spatial domain where we embed the watermark directly into the image. In terms of method of detection, we have a private way, requires original image at the time of detection to see, for example, everything is fine with the original with the transformed image, with the transmitted image. Sometimes we are talking about public or oblivious that does not require the original image at all. When we talk about a fragile watermark, it's likely to be destroyed and become undetectable out of friendly or malicious or any kind of attack that happen to the images. Fragility can be advantage for authentication purposes, so we can readily say that something wrong happened to the image, so we can discard it rather than accepting it. In terms of robust watermark, is the one that remains detectable after certain attacks. For instance, some common signal processing operations such as spatial filtering, lossy compression, printing and scanning, analog to digital conversion, resampling, cropping, and some intentional attacks. When we talk about semi-fragile, watermarking schemes are designed to make the system fragile against malicious attack, again tampering purposes, and they will robust against friendly attack such as tampering method, for example, like compression and so on. So for this case, this will be robust. However, for the malicious attacks, it will be fragile. So the semi-fragile tolerates some degree of JPEG compression because the digital communication system, the requirement is to transfer the data having low size, and for that purpose, compression is used. So it is normally considered as a friendly attack. In terms of the insertion method, we are having additive. This means adding the watermark into the cover or source image based on some key value. In case of images, the watermark is added to the pixel of the original image using some operation like exclusive OR operations. So first of all, we select the region where the information is to be embedded, and then the information is embedded by means of addition. However, selection of the area or the region of the image is potentially a question that we talk about later on. For instance, LSB is one of the most commonly used embedding mechanism because usually it's thought that if we even temper the least significant bit of the pixel of the images, it won't make any effect of the image perceptual quality overall. When we talk about quantize and replace, now this is somewhere we actually are flexible in embedding. So the watermark is embedded into the original image based on some quantization method. For instance, in spread spectrum watermarking, frequency hopping spread spectrum to determine position for watermark embedding in the original image. So this is normally done in a quantize and replace way. In spatial domain, when we are embedding something, it means that originally the images will be added, or originally the data will be added to the source image based on spatial domain criteria. So in this case, the least significant method falls under this fits all the copy of the original image at this receiver side. The most commonly used is the public one that does not require original image at the receiver side to extract the watermark. This is also known as blind watermark extraction, and the other one is be destroyed. So at least for the naked eye, it should not be perceptible. In terms of robustness, should survive accidental or malicious attempts at the removal. So in this regard, we sometimes also utilize error correcting codes that are most widely used in this regard. But at the same time, when we want more robustness, this means if you are using error correcting codes, means the data size will potentially increase. The data size increase would require more capacity. And if you're embedding more information in the watermark, so this will actually deteriorate its perceptual quality of the image actually. So the capacity is the number of watermark bits or size that is to be embedded. So increase in capacity will definitely affect the imperceptibility, and as well as it may increase the robustness. So robustness and capacity sometimes they go hand in hand. However, when you talk about the imperceptibility, that will capacity will hinder its quality. So the requirements are interrelated. For instance, with more capacity embedding caused degradation in the original image quality. Robustness need more information in capacity to protect the watermark. So the trade-off is always needed to meet these requirements. Whenever we are talking about some watermark system, so we have to actually make a complete pipeline where we can tell that what we want and what we can obtain with certain degree of trade-off. So what we are offering and what we want to obtain from the watermarking system. Some method involve training a neural network to insert visible watermark into images while preserving the original image quality at the same time. For instance, in this study, the watermark can be extracted from the watermark images using a separate neural network, allowing the ownership of the image to be verified, which is an asynchronous approach. Researchers and medical experts can collaborate to produce enhanced solutions in this regard. Finally, mainly the theme of my talk was about the digital image watermarking, and in particular, we talk about the medical image watermarking. However, this is not end of the story. We can enhance the same discussion for the voice-based for the image video-based digital watermarking, for other media-based digital watermarking. So all these areas are potentially regions to be explored in the digital in the deep learning era. So that is all from my side. Thank you very much for listening. Your questions are welcome.
Thank you, Dr. Taur Rahman, for a valuable talk. Next, it is my pleasure to introduce Dr. Saifullah Khan, lecturer in the Department of Computing and Mathematics at Manchester Metropolitan University, United Kingdom. His research focuses on cybersecurity, post-quantum cryptography, FPGA design, and secure hardware systems with publications in leading IEEE venues and impactful work across smart cities, blockchain, and space applications. Ladies and gentlemen, please welcome Dr. Saifullah Khan.
Hello, everyone. I am Safiullah Khan, and I am an assistant professor at Manchester Metropolitan University in Manchester, United Kingdom. And today I am going to talk about post-quantum cryptography, what is the current status of PQC, and what are the emerging research directions. First of all, I sincerely apologize I couldn't make it to the live event. This is because of some of my teaching commitments on that day and somehow because of the time difference. In my talk, I will be quickly reviewing about what PQC is, what are the current status. I will talk about this standardization process of some of the PQC algorithms. I will highlight my research and the research that I am currently doing in this domain. Starting from what cryptography is, or what is the traditional cryptography that we use today. So it is actually the established methods for securing our data and communication. The cryptography that we use actually relies on some of the hard problems and keys to encrypt our data. For example, we have RSA and elliptic curves, which belong to the family of asymmetric cryptographic algorithms. We have AES, which is a symmetric version of cryptographic algorithms. We already know that with the rise of quantum computers, there is a threat to the cryptographic algorithms that we use today. And the reason is that the quantum computers basically utilize quantum mechanics to perform computations that are way faster than the computations we can perform with the classical computers today. This is somehow a threat to the traditional cryptographic algorithms because of quantum algorithms like Shor's and Grover's algorithm. So the Shor's algorithm basically states that it has the capability to factorize large integers, and this is the hard problem upon which RSA relies on. If you can somehow factor large integers with a quantum computer, this means that RSA will be broken. The same is true for discrete log problems as well. On the other hand, the Grover algorithm somehow reduces the security of the symmetric cryptographic algorithms by halving the effective key length. This means that once we have quantum computers, we need probably double the key size of what the keys we are using for the symmetric versions of cryptography. In short, what is the implications to cryptography? The cryptography is vulnerable to quantum threats. The publicly cryptographic algorithms are vulnerable to Shor's algorithm. There is no mitigation available except designing new cryptographic algorithms with hard problems that are even resistant to the quantum threats. For the symmetric version of cryptography, this is vulnerable to Grover's algorithm, but the mitigation is increasing the key sizes. There is an urgent demand for post-quantum cryptography, which means that the algorithms that can withstand the quantum attacks as well. So the aim of PQC is to ensure the security of the data transmission, even in the era of quantum computers. Somehow, formal definition of what PQC is. So it refers to the cryptographic algorithms designed to resist the attacks from the quantum computers. There are a number of objectives of moving towards PQC. The first one is to deploy cryptographic algorithms that gives us security in quantum era. It ensures the long-term security of the sensitive data and communication channels. It's not just about designing algorithm, it's about facilitating the transition from what we use today, which are the traditional cryptographic algorithms, to the newer versions of cryptographic algorithms in the coming times. So what is the current status of PQC at the moment? So researchers have identified some of the hard problems that think they are resistant to quantum attacks. Here are some of the cryptographic algorithms hard problems. So the most famous among them is lattices-based problems. Most of the algorithms from the PQC domains right now are dependent on the hard problems that are lattices-based. We have some standards from hash-based and code-based as well. So in short, we do have some hard problems upon which the modern or the post-quantum cryptography is designed upon. NIST actually started a standardization process for PQC, and last year NIST published its first standards. So there are 4 algorithms that were published last year to be selected for as standards. The first one is MLChem, previously known as Crystal's Kyber, which is a key encapsulation mechanism. We have 3 digital signatures algorithms, Crystal's Dilithium, Sphinx, and Falcon, which were selected to be standard for NIST standards for post-quantum digital signatures. This year, we have a new standard, which is HPC, which is based on code-based key encapsulation mechanism. This is to diversify the CAM portfolio, because if you look at the first four algorithms, including the key encapsulation and digital signatures, three of them were based on lattices, and NIST actually wanted to diversify the portfolio by introducing in algorithms that are based on problems other than lattices. That's why we have a new standard HQC this year. What is the point of view from different governments and the regulatory bodies? So NSA in the US has provided its guidelines for related to migration as well, and it has given a transition window as well. So from the year 2025 to 2030, all the algorithms that we use will be phased out. And then from 2030 onwards, in US, they have actually mandated to use the post-quantum cryptography. Similarly, here in the UK, the National Cybersecurity Centre has published its own migration timelines. It's a phased strategy here where we are currently identifying the areas which are most vulnerable to quantum computers, for example, the health domain, the military communication. Regulators are basically emphasizing at the moment towards the hybrid deployments where we can use classical and post-quantum cryptographic algorithms together. This is to enhance a smooth transition period from one schemes to the other schemes. They're also prioritizing data that needs long-term confidentiality requirements. Industry has somehow adopted PQC as well. If you look at Cloudflare, major browsers, Chrome, Firefox, or other cloud providers, they have included PQC into the TLS domain. So now they are using Kyber, which is MLCAM now, along with some other algorithms, for example, X25519, which is a key exchange algorithm based on elliptic curves. So with this, they have somehow come up with the hybrid TLS, including the post-quantum algorithms as well. This doesn't come free. Definitely, it has some practical consequences. The key sizes for the newer algorithms are large. The signature size are larger. You need to update hardware security modules, and they are also prone to side channel resistances. So there are lots and lots of challenges when it comes to implementation and practical deployments. In the short term, what we are looking at, definitely we are looking at hybrid CAMs, for example, a hybrid solution combining both PQC and the traditional cryptography, update the TLS stack, update the HSM firmware signing positions. So this is something that we are doing in the meantime before fully moving towards the post-quantum algorithms. We can find applications of PQC everywhere. Blockchains, once again, depend heavily on hashing and digital signatures. Similarly, the government and military communication or the sensitive information which we are currently encrypting with traditional ones have to move towards the PQC. There are some implementation challenges, or we can say the current research directions. So the first one could be the performance considerations. The newer algorithms are computationally complex. They require efficient solutions for their implementations. They have a large key size, which means they require more bandwidth. The integration with the existing systems is challenging. We are looking for standards that can interoperate with the traditional algorithms that we use today. So these are some of the challenges that we have while we are migrating towards these newer standards. I mostly work with the implementation side, so now I'll talk a little bit about my research. I've been working by implementing MLCAM, which is known as Crystal's Kyber as well, which is a post-quantum key encapsulation mechanism, and it belongs to the family of lattice-based cryptography. The underlying problem for MLCAM is module learning with errors, and which is somehow more superior to other schemes, for example, ring learning with error schemes. I mostly work on implementation with FPGA platforms. There are a number of implementations of PQC that we can find in literature, and my job is to implement and make these implementations very specific to certain applications. The applications that I have been mostly working with is in the domain of space missions, because there is an extra challenge introduced when we are implementing these algorithms for space missions. And the challenge is that since the FPGAs are based on SRAMs, so when they are prone to radiations, they actually introduce a single event upsets, which means that some of the bits are flipped due to the radiations. If there is a bit flip during encryption or decryption process, which means that the entire result will be completely different. If we have encrypted something which is erroneous, we cannot decrypt it back to the original plain text. So somehow we have to take care of this single event upsets as well. With one of my latest research, we have actually proposed an architecture to compute a polynomial multiplication, which is a major component of MLChem. And in order to compute polynomial multiplication, we are doing it through number theoretic transforms. So we have designed an architecture for entity with not just only compute entity, but can also detect and correct errors as well. We have implemented it on different FPGA platforms, and I will definitely show the results once I have discussed this. Inside this entity, one of the major component is a reduction unit, modular reduction unit. The modular reduction unit is designed using the Barrett algorithm. Since the mod value Q for Kyber is fixed, so that's why we have pre-computed some of the values. The multiplication involved is computed through schoolbook approach, and we design a Barrett reduction algorithm here. An architecture that is based on the Barrett reduction algorithm. Once we have this basic architecture here, which we can see here as a small box as mod, then we design the entire entity architecture. So number theoretic transform is basically a multiplication process where we take some coefficients of the polynomial, some trivial factors, and multiply together and store the results. So there are register banks here at the input and the output side, and then we multiply them, take the mod, store the results at the output here. So during the start of computation, the coefficients are first loaded into the registers, and then each clock cycle, two coefficients are read from the register banks, multiplied, and the output is stored in another bank of registers. And this happens sequentially. Once all the registers are stored in the register banks, the computation for the second layer starts, because there are a certain number of layers within the entity structure. So this is the basic architecture of entity. But what I do is somehow modify this architecture to introduce some capabilities where it can detect the errors and it can correct the errors itself. And for that, I have introduced some parity bits, some Hamming weights. So I compute some Hamming weights here, which are stored in the register instead of, along with the twiddle factors, and then repeat all the computations here. So the architecture shown here basically introduce extra capabilities of error detection and correction as well. So we compute the Hamming weights for each twiddle factor, and we only not just only save the Hamming weight, but we also saved it. Not only just save the twiddle factors, but also save their Hamming weights as well. So the butterfly core, which computes the entity, runs the same way, and inside the butterfly core, the Hamming codes are computed again and compared with the Hamming code that is received. If there is a bit flip, definitely they will not be the same, and the corrected output is then processed to the standard entity computations again. The same is true for the value of the coefficients that we store. We compute the parity for each of the coefficient that is being computed by entity. And if there is a bit flip in the computation, the parity bits indicates a bit flip. And if there is a bit flip, we just trigger the reset signals to do the computations all again. So this is the basic architecture that we have proposed in our work. When it comes to the results, I have computed the results on FPGA for the basic architecture, for the one where I have introduced the Hamming codes, and the other one where I have introduced Hamming codes plus parity bits. So the thing to be noted here is that there is some kind of percentage area overhead. Although we have increased the area, but the implementations that we have made are now more much more suitable for certain application, which is the space application in our case. So that was all about my talk. Thank you so much for listening. I have tried to introduce the concept of post-quantum cryptography, its implementation, standardization process, and the application that we are doing specifically in the space applications. Once again, I apologize, I couldn't make it to the live event. So if you have any questions, you can send me an email. I have put my email address here, and I will look forward to your emails if there are any questions. Thank you so much for your time.
Good morning, everyone. It's a
Thank you, Dr. Saifullah, for the valuable talk. Our next speaker, Dr. Hola Taji, now will deliver her talk. Dr. Taji is a researcher affiliated with Job Dokali University in AI Jadida, Morocco, where she contributes to academic research and development within her field. Her work reflects a commitment to advancing knowledge and supporting research collaborations at an international level. Ladies and gentlemen, please welcome Dr. Hola Taji.
Good morning, everyone. It's an honor to be here with you at this international conference to discuss one of the most transformative intersections in modern technology, so the convergence of artificial intelligence and blockchain. My name is Khawla Taji. I'm assistant professor at Shuaib Kali University in Good morning, everyone. It's an honor to be here with you at this international conference to discuss one of the most transformative intersections in modern technology, so the convergence of artificial intelligence and blockchain. My name is Khawla Taji. I'm assistant professor at Shuaib Kali University in Morocco, and over the next 20 to 25 minutes, I will walk you through how artificial intelligence and blockchain are shaping the next generation of secure, intelligent, and autonomous systems. So before diving into the technical depth, let me give you a short roadmap of today's talk. So here's how we'll structure our journey today. We'll begin with a quick overview of blockchain technology, followed by a look at the evolution of blockchain from Bitcoin to blockchain 5.0. Next, we will introduce the fundamentals of artificial intelligence and then explore how artificial intelligence and blockchain complete another. So also we'll examine common attack vectors, IA-enhanced security, and IA-driven scalability. Then we'll explore real industry use cases, discuss research challenges, and finally look toward the future directions that will be defined the next generation of intelligent decentralized system. So to build a common ground, let's first revisit the foundations of blockchain and why it matters. So the blockchain is essentially a distributed ledger, shared database that records transactions across many computers, so no single entity controls it. Imagine a digital ledger replicated across a global network. Every transaction is grouped into blocks, which are linked in chronological order. Once added, these blocks are nearly impossible to alter without detection. That is the core idea of decentralized trust and transparency without relying on a central authority. This revolutionary design enables everything from cryptocurrency to supply chain tracking. But as powerful as it is, traditional blockchain faces real limitation when the network scales or when rapid, intelligent decision making is required. Now that we know what blockchain is, let's trace how it has evolved over time. So blockchain 1.0 began with Bitcoin enabling decentralized financial transaction. We moved to blockchain 2.0 that introduced Ethereum and smart contracts, transforming blockchain into a programmable platform. Blockchain 3.0 addressed scalability and interoperability challenges with projects like Cardano, Polkadot, and Cosmos. We have Blockchain 4.0 entered enterprise ecosystems supporting supply chain, IoT, and industry scale applications. Today, we enter Blockchain 5.0, where blockchain converges with artificial intelligence to create systems that are autonomous, intelligent, adaptive, and self-optimizing. Although blockchain is a powerful technology, it still faces several key limitations. Now we can talk about the scalability. Remains a major issue. Many blockchains struggle to process high transaction volumes efficiently, leading to delays and rising costs. Second, energy consumption, especially in proof of work system, raises sustainability concerns. Third, storage requirements grow continuously as the blockchain expands, making it harder for nodes to participate. We also have interoperability challenges. Most blockchain operates in isolation and cannot easily communicate with one another. Finally, privacy and regulatory uncertainty continue to slow down adoption, especially in sensitive or highly regulated industries. This limitation highlights the need for new approach and complementary technologies such as artificial intelligence to unlock the full potential of blockchain. Now that we understand the challenges, let's move on to a key component that keeps blockchain networks functioning reliability, which is the consensus mechanism. So the consensus mechanism allows participants to agree on the state of the ledger. The most widely known is proof of work, which relies on computational effort to secure the network. It's robust but extremely energy intensive. Other approaches exist, like proof of stake, reduces energy use but can concentrate power among wealthy holders. We have, for example, delegated proof of stake speeds up processing through elected delegated, but raises question about partial centralization, and we have other approaches. So now each method trades off security, speed, decentralization, and cost. The challenge is finding the right balance for a given use case. So as network grow, consensus becomes even more demanding. That's where artificial intelligence can step into to optimize this mechanism. But first, a quick refresher or on artificial intelligence itself. What is the artificial intelligence? So artificial intelligence aims to mimic human-like abilities, perception, learning, reasoning, decision making. It allows machines to analyze massive data, spot patterns, and make autonomous decisions. Key approach include machine learning, deep learning, reinforcement learning, natural language processing, generative AI. These capabilities have already transformed many industries. Now consider them applied to blockchain's toughest challenges. Let's explore how artificial intelligence can help blockchain directly. So in the slide, we will explain why combine artificial intelligence and blockchain. When artificial intelligence and blockchain converge, they form a powerful synergy. The artificial intelligence brings adaptability, predictive power, and automation. Blockchain brings security, transparency, and decentralization. Together, they can tackle key blockchain challenges: scalability by predicting congestion and optimizing resources, security by spotting threats in real time, automation through smarter contract handling and reduced human error, model integrity by ensuring artificial intelligence model on chain remain trustworthy. This integrated approach helps systems scale to enterprise levels while maintaining trust and efficiency. We'll now look at the specific artificial intelligence technologies that can be applied to blockchain systems. Various artificial intelligence can be woven into blockchain to address distinct issues. For example, machine learning. We can use it for anomaly detection, fraud prediction, and performance forecasting. Deep learning for advanced security tree detection and vulnerability scanning. Reinforcement learning for self-optimizing consensus, adaptive block sizes, and dynamic resource allocation. Natural language processing to interpret legal language and automate contract generation. Generative AI to draft, optimize, and audit contrast, and even validate artificial intelligence model automatically. Each technique adds a layer of intelligence, turning a passive ledger into a responsive, adaptive system. So one of the most important area is consensus itself. So one of the most impactful areas is consensus itself, as I told. Let's dive into IA-driven improvement there. So the IA transform consensus mechanism from static rules into dynamic intelligent systems. We have the dynamic parameter calibration. Artificial intelligence can adjust consensus parameters based on real-time network conditions, keeping performance optimal even when loads vary. Intelligent validator selection by analyzing past behavior and contributions. Artificial intelligence can choose validators that maximize security and efficiency. Workload prediction. Artificial intelligence forecasts transactions load, preventing bottlenecks during peaks. Energy optimization, adjusting mining or validation intensity to reduce energy use, while maintaining security, addressing environmental concerns. Underlying methods like reinforcement learning, time series prediction, and clustering enable these capabilities. The result is consensus that learns and adapts instead of remaining fixed. So beyond consensus, security is another domain where artificial intelligence add a leap forward. On this slide, we bring together two essential views of blockchain security: the attack that threaten blockchain's network and the artificial intelligence-powered countermeasures designed to defend against them. Understanding this dual perspective is crucial for building resilient next-generation decentralized systems. Let's begin with the attack landscape. Blockchain networks face a wide variety of threats. We have, for example, 51% attacks where an attacker gains majority control of computational or second power and can alter the order of transaction. We also have Sybil attacks when an adversary creates many fake identities to influence consensus or disrupt the network. Another major category is smart contract exploits. Vulnerabilities in contract code, such as reentrancy or logic flows that attackers exploit to drain funds or manipulate outcomes. Oracle manipulation is another common vector. If external data sources are compromised, smart contracts can be forced into incorrect decisions. And in decentralized finance, front-running and MEV attacks have become especially damaging, allowing attackers to reorder pending transactions to gain immediate profits. Finally, we have phishing, private key theft, and predict network congestion before it happens, helping blockchain adjust resources proactively. It also improves how validators are selected and balanced, making network faster and more efficient. With dynamic block sizing, artificial intelligence can adjust block sizes in real time based on demand, and smart energy optimization reduce costs while maintaining strong security. These aren't just concepts. There is already powering real-world use cases, high-frequency trading with millisecond settlements, uh, Internet of Things network handling millions of devices transactions, and supply chain system processing global tracking data in real time. In short, artificial intelligence transforms blockchain into a more scalable, adaptive, and truly enterprise-ready technology. So in this slide, we'll explore the benefits of integrating artificial intelligence and blockchain. Let me walk you through why combining artificial intelligence and blockchain is such a game changer. When these two technologies come together, they don't just adapt, they actually enhance each other. First, scalability. Artificial intelligence helps blockchain handle way more transactions, which means they can finally support large real-world applications without slowing down. Second, stronger security. IA can spot unusual activity early and predict potential threats before they turn into real problems. So instead of reacting, we can stay ahead. Third, fewer errors. By automating things like contract checks and validation, artificial intelligence reduces human mistakes and keeps operation running smoothly and reliably. For more transparency in artificial intelligence. One of the big concerns with artificial intelligence today is trust. Blockchain helps by creating an auditable trail of decisions so we can see what happened and why. And lastly, adaptive systems. With continuous learning, the systems can adjust and improve on their own as conditions change. So in simple terms, when artificial intelligence and blockchain work together, we get smarter, safer, and more trustworthy systems built for the future. So theory is powerful, but real-world example shows that what's possible today. So several global leaders are already pioneering practical applications. IBM, for example, combines artificial intelligence and blockchain for supply chain intelligence. Their platform detects anomalies, improves traceability, and helps prevent contamination or waste. We have the Microsoft company uses predictive analytics to tamper-proof blockchain records in its Azure services, giving enterprises verified data for confident decisions. We have also Alibaba applied artificial intelligence and blockchain for food safety and prevent fraud across its ecosystem, protecting consumers and brands. Vici integrates IoT sensors, IA predictive maintenance, and blockchain to manage risks in manufacturing and logistics, creating reliable compliance records. This case proves that the integration is not just theoretical, it's delivering real value across industries. Yet, as promising as this is, we must also be clear eyed about the challenges. So we move on future research challenges. As we move toward intelligent decentralized system, several research challenges still need your attention and our attention. So first, we must address ethical concerns such as bias, fairness, and data privacy to ensure responsible artificial intelligence behavior. Second, interoperability and standardization remain essential so that different blockchains and AI systems can communicate seamlessly. Third, we face scalability issues as we discussed. So artificial intelligence, computational demands must align with the limitation of distributed networks. Finally, we must improve the transparency and explainability, ensuring that artificial intelligence detection and decision remain understandable, auditable, and trustworthy. These challenges highlight the need for continued collaboration between artificial intelligence researchers, blockchain developers, industry practitioners, and policymakers. So also looking ahead, the researchers and research in artificial intelligence blockchain integration is moving towards several high impact priorities. One key direction is verifiable IA on chain, where blockchain is used to cryptographically prove the correctness of artificial intelligence decisions. Another is explainable AI, ensuring that automated decisions remain transparent and easy to audit. We also seen strong interest in artificial intelligence driving DAOs, where decentralized organization can make smarter data-driven decisions autonomously. In parallel, the field is progressing toward decentralized artificial intelligence models, reducing reliance on centralized data storage and improving resilience. And finally, privacy preserving learning, combining federated learning with blockchain, while also allow collaborative model training without exposing sensitive data. Together, these priorities aim to build artificial intelligence blockchain systems that are not only powerful but also trustworthy, interpretable, and scalable. As we near the end, let's summarize the big picture of this keynote presentation. So the integration of artificial intelligence and blockchain represents a paradigm shift. So artificial intelligence enhances blockchain's scalability, security, and automation. Blockchain also secures artificial intelligence integrity and trustworthiness. Together, they form a foundation for intelligence, decentralized systems that can transform industries, governance, and society. As we move beyond current generations of technology, this convergence will power autonomous network, Web 3.0 ecosystems, and new digital realms, where systems are not just smart but also trustworthy and adaptable. The future belongs to solutions that are both intelligent and secure, decentralized and efficient. This is where innovation must focus. So, thank you very much for your attention. I'd be delighted to discuss any question you may have, or to explore how artificial intelligence can especially transform blockchain in your own context. Whether it's practical applications, challenges, or future directions, I'm here to provide insights. Please don't hesitate to reach out later if you think of questions or want to with you and exchanging ideas. And thank you so much. Goodbye.
A big thank you to Dr. Khala Taji for inspiring and thought-provoking session. Let's once again thank you our speakers, our patron-in-chief of ICCI, and our conference chair for their presence. We will now take a 1 hour break. Ladies and gentlemen, session 2 has now concluded. We will take a brief break and the session will resume at 2:30 p.m. Please be back on time to continue with the exciting program of ICCI 2025. Thank you so much.
Assalamu alaikum. Hello.